This conference will now be recorded.
Yes, good morning everyone. My screen and audio both are fine or not, please confirm.
Yes.
Yes. So, how many not visible? Is my screen and audio both are fine or not online? Please confirm.
Fine, sir, fine.
Okay. Welcome everyone to physical design demo session. Okay. So before starting, right, before start of this demo session, I would like to tell how we are going to proceed. So I will be going to tell you about the course structure. So what are all topics which we are going to cover in this complete course? What will be the course duration? Whether basics and advanced both topics will be covered together. So how it will work? So everything will be explained in course structure. So uh, how we are going to proceed with placement support and interview preparation. Those questions will also be answered and it will be explained. Chip design, so I'll give you some brief on what we are going to learn in this course. So what is chip design? What is chip fabrication? What is the difference between them, right? And how these all process works, how industry works. So what flow we are following here? What is the process of fabricating a chip, designing plus fabricating a chip, and some advanced physical design concepts also. I will give you some briefing so that you can understand what we are going to learn in this course, right? So that you can get some idea. And what happens once everything is completed, once design is completed, so what happens next? So there will be some checks, verification, and then final tape out. Tape out means it is just like a going to the fabrication lab for fabricating the chip. So we are going to follow in this structure. So first is what is our course structure here in this institute. The total duration will be 6 months, at least, I'm saying. Sometimes it may go to 7 months also, sometimes 7.5 months also. Why? Because it depends on batch to batch. So if your batch is fast enough to grasp concept, if they can match with the speed of mentor, right, then it might complete in at least 6 months. But sometimes what we have seen from our past experience with respect to batches, right? So some people will need some extra support, extra help, need some extra classes also. That will also be provided. Based upon that, duration will extend. It will not complete in 6 months. That is very clear. So the first 2.5 months for everyone, for every batch, there will be PD basics. So PD basics will be covered in 2.5 months. Next will be PD advanced sessions, right? So in PD Advanced, purely PD subjects or PD concepts will be taught, and lab experiments and lab projects will be given to you, where you are going to working on real time tools, right? What tools? Those are called as EDA tools, electronic design automation tools. So here we are going to give you hands-on on licensed EDA tools, which is not freely available in market, right? So the license has to be purchased, which is very costly. So that is why those license will be provided only once PD advanced sessions will start, right? We'll discuss. I will tell you more furthermore how it will work. So overall, it will be 6 months duration of course. First 2.5 months will be PD basics. Like we are not going to cover all electronics basics, right, which is required for PD advanced session. The basics will be covered that much only, which is required for our PD advanced session, right? Like what? Can you tell me any subject which is required for VLSI, the basic subjects? Very important subject.
So
What is that?
transistors, gates.
Correct. Digital electronics is the first most important subject. Then, yes, DLD, or you can say digital logic design, digital system design subject, or digital subject majorly. So it is the most important basic subject which is required to understand VLSI. First subject. Then CMOS, right? In PD, we also require CMOS. Without CMOS, we know that most of the chips which are getting fabricated, it is based upon what? CMOS logic, right? Right. Yes, we have latest one also. We have FinFETs, we have GAPETs, we have latest one, but those are below 14 nanometer, below 28 nanometer technology nodes, right? But above 28, above deep submicron region, we have mostly what? CMOS based logic designs, right? So CMOS based logic design means, so any design which is designed using what? CMOS circuits. So basic CMOS circuit is nothing but an inverter using PMOS network and NMOS network, right? So those all, so these two are the most important core basic subjects which will be covered in the PD basic session, right? Apart from that, we will also cover what? Some other things also, right? Other subjects, other concepts also, which will be helpful in your job profile, right? When you will going to some company, right? You will be selected in some company. So there you might need GBIM skills also, right? GBIM is nothing but a text editor, like a notepad which you use, right? So you might need those skills also. You might need Unix and Linux commands, right? Basics. Why? Because you know that industry works in what? Majorly Unix based environment, right? Or Linux based environment. It does not works on Windows. So most of your projects will be on Linux environment. So that basics will also be covered in this PD basic sessions. So apart from that, some coding languages, some coding knowledge, right? Some scripting knowledge is also required in physical design domain, right? Like majorly TCL will be taught to you here, because TCL is nothing but tool command language, right? It is in short, some people will call it as tickle also, right? TCL is nothing but tool command language. So why TCL? Why we should learn TCL? Because the EDA tools which we are working on, right, it is called as ICC2 Synopsys. It is a tool from Synopsys, which is a licensed tool, which is developed on this scripting only, which is developed on this coding style only, that is called as TCL. That is why if we learn this TCL subject, it will be helpful in our physical design also. Handling the tools, handling some operation, handling some routine task. It will be helpful there. So that will be also covered in PD basics. So next, like I said, so we require two core basic subject knowledge. That is one digital, second CMOS, right? And then some physical design basics will also be covered, right? Like what is the flow, what we are going to do in physical, what are the steps, what are the stages, what is the first stage, what is the next stage of designing, what is the third stage of designing, that will be given in brief during what PD basics sessions, right? So class timings, so how class timings will work? Of course, there are different level of students and different work profile of students. Some students are what, they are looking for job opportunity. Some students are already in their job profile, some job, maybe in computer, maybe in IT, maybe in software, maybe in cyber security or networking, right? So for working and for non-working, right? So for non-working, you will have weekdays timing from Monday to Saturday. So I think maybe Friday or maybe Sunday will be holiday for you. It depends when they give you, according to batch, that will be decided. So your daily session will be of 3 hours. Okay. Theory session will be conducted only on Saturdays and Sundays. Why? Because working and non-working both can attend those sessions. Because we are going to provide you with some industry experts. So they are only available on weekends. They are not available on weekdays. So they will be helping you with the theoretical concepts, the analytical concepts only on weekends, because the weekdays they are not available. Okay. So weekends, your theory sessions will be there, and weekdays, your lab sessions will be there. Lab session timing will be, the duration will be 3 hours, and the timing will be decided according to the batch requirement. Suppose the batch is okay with the morning session. So morning session, it starts from 9 o'clock to 12 o'clock. Okay, 3 hours. Or some batch may say that no, we don't want morning session, we want post lunch session. So it will start from 2 o'clock. So 2 to 3, 4, 5. Till 5 your session will be there. So you have two slots. Out of that depends on batch to batch. What majority of students says in that particular batch, the duration, the timing will be decided according to that only. So it is also flexible, right? For non-working students. Now what about working student? How they are going to do lab? Because in weekdays working students are not available, right? Only weekends they are available. So for them, morning session will be theoretical session and afternoon session will be lab session. For whom? For non-working students. Oh, sorry, for working students. Those who are going for some other jobs, right? They don't have time in weekdays. So on Saturday, Sunday, both theoretical concept as well as lab session will be conducted. Okay. So what are all learning resources which are going to be provided to you? So in learning resources, we will provide you one hard copy material of notes in physical design as well as physical design basics, that is digital, CMOS and TCL. So we will give you one printed notes where you can study. That is one printed hard copy material. Apart from that, same material can be found as a soft copy in the VLSI Guru website also. You can visit the VLSI Guru website and you can access the soft copy of those materials. So when you will get the access like login credentials and password, you can go through those website and you can access soft copy also, right? So this is about what notes and what material which is going to be provided to you, right? This is first. Second thing is that every session, each and every session, whether it is theoretical or lab session, both will be lively recorded, right? Live sessions will be recorded. Why we are giving a recorded session? Because sometimes what happens, you are attending live sessions, so sometimes we miss some concept, we will not understand some concept. So again you can go back and you can see those recorded session and understand, right? That is what we think it will be helpful to you. Secondly, what happens, sometimes due to some emergency, due to some other reasons, you might not come to the live session because of some emergency work. That time what you can do, you can watch recorded session which you have missed attending live. But don't take this as what, like don't misuse it, right? Misusing means what? Even though if you are not having any emergency work, you're still sleeping at home, right? Doing nothing, chilling out with friends, at that time there is no use of recorded session, right? That is not correct. That recorded session giving, the purpose is to, if you miss any live classes due to some genuine reason, then those recorded session will be helpful for that missing class, so that you can cover up. So live recorded videos will be given, and pre-recorded videos will also be given on request. Okay, clear everyone? Any questions here regarding timing, regarding topics which we are going to cover, and learning resources? So this is about PD basics. Clear? Any doubts in PD basics regarding timings, regarding materials, regarding topics which we are going to cover? Right.
Is it
Next is,
is it possible to change timings only for Friday, Saturday?
it. Like I said. So if you are working, right?
The thing is, like, actually, I'm attending from America, so only Friday, Saturday, these timings from 9 o'clock, like, I will be in like part time, so I just
Okay. So you are working or non-working?
not working. Just I graduated. Like, I'm looking for jobs, so just doing part times in America
Okay.
weekends,
So
only Friday, Saturday.
right, I got your point. So it is about the different time zone, right? So when we are having a live session here, so that time they will be sleeping there, right? Of course, it is a
Yeah,
good point. So yes, in that case also you can shift to the working batch session, right? Means the people who are working people, right? In that batch you can shift. For them, Saturdays and Sundays will be both labs as well as theory sessions, right? Only on Saturdays and Sundays. But thing is that different time zone is there, right? I am not sure whether any night session, whether it will be conducted or not. I
no,
haven't
no,
seen.
no. Like, I'm okay with like non-working days, like full weekdays. Like, I'm just like only Friday, Saturday, around 9:30. It's like sometimes difficult. Like, I may miss some classes. Just only Friday, Saturday.
Sure, you can shift
Uh,
to Saturday, Sunday in that case. You can attend live session. This is only for live session. But remember
yeah,
that each and every live session is recorded, right? Those are
yeah,
lively recorded. In case you miss it, right? In case you miss it, you can take help of recorded session which will be given to you after each live class, right? So that is also, that flexibility is also provided by us. Okay, for non-working student who are present in India, they can attend for weekdays, right? Weekdays means from Monday to, right? So Friday, Monday to Friday, sometimes Monday to Thursday also. So Friday you might get holiday, right? So in these days you will have lab session, right? Only lab session. It may be morning, it may be afternoon, it depends on batch to batch how it goes. Then secondly, you have that flexibility, you can choose on morning or afternoon session, it depends. Secondly, what happens on Saturday, Sunday for weekday students or non-working students? For Saturday, Sunday, you will only have theory sessions. So this theory session and the theory session from working, right? This is common, right? Both will be attending same live session. So theory session will be common for both working and non-working students. Okay. So on Saturday, Sunday, industry expert will be coming for you, which will be teaching you advanced topic, PD advanced topic. Clear?
yeah,
Okay. PD Advance, in PD Advance, we will cover approximately at least 3 months to 4 months. So sometimes, mostly it goes to 4 months only. But if we have seen some batches, like some rare batches, which are very fast in grasping concepts. So in that case, your course might complete in 3 months also. but that is the at least, right? But on an average it goes for 4 months, right? The duration of PD advanced sessions. So which tools we are going to use in physical design here? That is Synopsys Design Compiler, DC, Synopsys ICC2 tools, Fusion Compiler, ICV, Prime Time, and Star RC. Right? What are these tools? What is the purpose of these tools? Right? So design compiler, I will tell you in later on also that it is used for synthesis, right? ICC2 will be used for PNR flow or physical design flow. Fusion compiler is the compilation of Synopsys tools. So these are called as what? EDA tools, electronic design automation tools. These tools are called as EDA tools. Similarly, from Cadence also, similar type of tool is also available. So what Synopsys is providing? Same work, whatever designing work we are going to do using Synopsys ICC tool, same work can be done in Cadence tool also, right? So Genus is similar to DC. Innovus is similar to ICC2, right? Tempus is similar to Prime Time, right? Both are both are helping in same work, right? So thing is, what is the difference? The GUI is different, graphical user interface is different, the way of operating is different, some operations and some features are different, some commands are different. That is the only difference here. Can weekend students attend online of weekday classes? Weekend students attend weekdays. Yes, you can, if you want, you can opt for weekdays session also if you are available for weekdays. But thing is, you cannot shift to some days weekdays and some days weekends, because what will happen? There will be different pace in lab session in weekdays. I mean weekend and weekdays. So maybe you are learning floor planning. The other batches, which is weekend, they might learn placement. So it's not practical there. If you can cope up, you can attend. Yes. Okay. So these are the EDA tools which will be covered, or which will you will have the hands on in the PD advanced session. Yes, I will tell you, Manoj, which topics will be covered in PD advanced session. I will discuss in briefly. So course structure is Monday to Thursday, like I said, labs and projects will be driven on for weekdays batch. For weekend, lab session will be on Saturdays and Sundays, like I said. So timings are flexible. So institute opens at 9 o'clock, 9 to 5. So between this, there are 2 to 3 slots. So one slot is at morning session 9 to 12. Then there might be some one more slot that may be from 12 to 2 o'clock, right? That is rare slot. And then you have another slot of 2 to 5. In these three slots, your timing can be decided. I have one backlog in BTech. Is it good to take this course? So it depends whether you are in final semester or which semester. If you are in final semester, yes, you can take it, right? Why? Because the backlog which you are having, right? The exam which you are going to give, that will start this December or when. So it depends on timing also. BTech already completed. So when is your exam? I think this winter session only, right? December only. So in that case, yes, you can take it, because by that time your course will also complete and your subject will also clear. So you will have a degree on your in your hand. So you can start applying for jobs also. If you are confident in that subject, if you think I cannot manage that one subject and this course, then in that case you should focus only on that particular subject which you have backlog. You should not focus on two things in that case only. If you are confident it is only one subject, yes, we can handle it, right? So that is the best, it is the best that you carry course also with yourself. By that time what will happen, your subject will also clear, and 3 months will not be wasted on that one subject. Your course will be like 60% completed, right? So you will have degree in 1 or 2 months, you will get result also. By that time, your course will also complete. So that this is the ideal which will be helping to you. Will companies consider regular pass out year? Yeah, it does not matter whether you have backlog pass out or not backlog pass out. They won't look on those stuff, right? Only thing is that you should have a good average percentage, right? You should be having a degree, at least provisional degree in your hand. Then you can start applying in companies. So what they are going to look, they will be looking you as a fresh trained candidates in physical design. They are not looking for freshers. There is a difference between freshers and fresh trained physical design candidates. So who has the upper hand? Of course, fresh trained physical design candidates, because they have hands-on EDA tools. What industry is working, you have that already, that knowledge, concept knowledge is there, basic knowledge is there, plus what is next, you have hands-on licensed EDA tools which is not freely available, which all these things which freshers do not have, a pass out does not have, right? So if you are a MTech pass out, then maybe you might have worked on some EDA tools also. But conceptual knowledge, industry level knowledge, you will get that in this institute only during this course period. Okay. Yes, so tool access. Yes, good question, Giriraj. Yes, tool access will be given 24 hours, right? 24 into 7. All days tool access will be available. There are no slot system here. So complete tool access will be given to you once you enter into what? PD advanced session, right? It will be not given you in PD basic sessions because it is not required. So it will be completely theory sessions there. Maybe some mentors take some lab session also, demonstration for demonstration purpose only. But in PD advanced, once you start PD advanced session, what will happen? Tool access will be immediately given to you. So for 4 months, 3 to 4 months, you will have complete tool access. Even after completion of course, extra 15 days of buffer will be given to you. 15 to 20 days of tool access buffer will be given to you, so that course completed, some people may have some pending project work, right? So they can utilize that time. Some people needs extra practice. Some people needs revision in tool practice also. For that purpose only, we will be providing you extra 15 to 20 days of tool access, even course completes. Understood? I'll write it here, this point. This is very, so regarding tool access. So which is provided 24 into 7, right? This is first point. Second point, what I have told, that even course completion, post course completion, right, extra 20 days will be given, right, for practice. This is about tool access, EDA tools, Synopsys EDA tools or Cadence EDA tools, right? Clear everyone? Any questions here? Yes, Vignesh, I'll discuss about placement also. Yes, we'll go to next slide. Yes. Now comes what about placement support and interview preparations, right? So here, how we are following. See, the placement support can tool access through our laptops, or does it require any special requirement? No, no, nothing special requirement is given, not required. So you need your laptops. That's all. So we'll be giving you access, right? So the tool, giving a tool means what? It is not any installer or any application. Tool is there with us only. The access will be given to you. It is in our server, right? Okay. Whether screen is visible for everyone, because one person is telling me that screen is not visible. The PPT slide is visible. Okay. So you can check, Dhara, you can check once with your network maybe. Any chances for bulk or mass hiring or trained freshers in upcoming year? Yes, Anand, I'll explain that also, that point also. Don't worry. Okay. So in placement and support and interview preparation, see, this is where you should understand very clearly that without any preparation, no one is going to select you, right? Even though you complete a course, you get a certificate. Based upon that certificate, do you believe that whether anyone will select you? Whether certificate is that parameter to select you, or the knowledge or the hands-on or the skills you are having, based upon that you will be selected. Which one is true, first one or second one? Of course second one, right? No company is want any person who does not have any skill, who does not have any hands-on. No one wants your certificate actually, right? Only thing what they want work from you. On an exchange they will be providing you salary. This is the simple equation we know about these jobs, right? The thing is, give importance in the preparation itself. Take it seriously. Don't miss any live classes. Don't miss any test which is provided to you. So for all those, the preparation, the best preparation, so whatever resources, whatever the course, whatever requirement is there, we will provide to you. Now what is those requirement which will be helping you in development of your skills in your hands-on and developing your physical design concepts? So we will be regularly giving you assessment tests, and so that you can track your progress, right? You can see how much I have learned, where I am missing, which concept I am not understanding, right? So even lab sessions will be completely with you only, right? Once lab session completes, you can go home and you can practice. You can practice here also. If you have any doubts, mentors are available on weekdays. The lab session mentors are available. You can ask doubts, you can ask question, you can clear your subject, right? So then comes mock interviews. Once course is in the ending phase, like last month, so your mock interviews will start. Why? Because only having the knowledge of subject, only having the knowledge on hands-on on tools will not work for you. So you should be good communicator also. Your communication skill, your language, the professional language skills, those should be good, right? Secondly, not only that, even the knowing is not sufficient. The expressing is also very important with knowing, right? What we will teach you, you will know it, you will understand it, you have good grip in concept, you have hands-on, whether you are able to express that in mock interviews or not. So how to express those things, how to answer those questions, right? How to answer twisted critical questions. Those all things will be covered in mock interviews. So you will be provided, we will be giving you with some mock interviews once your course is going to complete, so that you can track your progress, how I am performing, where I am lacking, whether my communication is good or not. So we will be giving you feedbacks also, that you should improve your communication, you should improve your this subject, you should improve your basics. CMAS is not good, CMAS is weak. Like that, we will
Mhm.
be giving you feedback also, so that you can improve
లాస్ట్‌కి
specific
ఇక్కడే
area.
సెట్ అవుతది. ఈవినింగ్ సెట్ అవ్వాల్సిందే. ఒకసారి
Yes,
మెసేజ్
yes.
చేయండి. ఓకేనా?
Any doubt? Okay. So understood. So don't be in this, what we say, don't be in that zone. That certificate will work. Certificate is just that you know it, but you have to prove that certificate, right? And that will be proven in written test or in mock interviews, which will be taken by companies. So what institute, any institute, what any institute, not only this institute, what any institute does, they give you opportunity, right? So getting opportunity is difficult in VLSI. So institute will help you in getting you the right opportunity, which will be helpful in your growth and in your career, right? That is our part, bringing you the opportunity. The cracking that opportunity is completely based upon your part. How much you have learned, how much skills you have developed, how much you are cooperating, how much effort you have given in preparation. That all depends on you. So that will help you in landing up in a good job. Okay. So not only this, before interviews, the first thing comes is what, resume building, right? You should have proper resume also. That kind of support will also given here. Like in resume, how we should write, what should be the font, what should be the grammatical things, right? There should not be grammatical mistake. What should be the order, which one should come first, right? All those things will be covered in resume building. How your resume should look best, so all those things will be explained in resume building session, right? Not only this, uh, regularly we will be providing you with soft skill session also. Soft skill training means what? So that you can improve your communication. So you will have some exercise, right? Exercise means what? Like public speaking, speech, group discussion, these kind of trainings we will give to you, so that you can improve while speaking the professional language which is used in corporates, that is English, right? So e-learner students can also attend soft skill session. There is there will be online link which will be provided for e-learner students also. For e-learner also you can attend live session. So the live session means both e-learners, online student as well as offline students, means who are attending from here, both can attend same live sessions. It is not like for e-learner online session there will be different live, and for offline there will be different live. No, the live session is single. It is common for both e-learner and online session, whether it is PD, whether it is soft skill, whether it is interview preparation session, all will be common for both online and offline students, right? Only thing is what, if mock interview is given for you, it will be online mode because you are not available in this location. Those people who are attending from institute, they can have face to face interview for better. Of course, face to face will give you more confidence if you have that face to face mock interviews. But due to some reason you might come, you might not come to this institute, so that in that case you can attend online mode of mock interviews. So test, similar for test and assignment also for online student, the question paper and everything will be on online mode. Sir, I am in my first year of MTech in VLSI design in NIT Hamirpur. I would have opted for weekend course, but that will not work for me. I have opted for weekday batch and I will attend recorded session after returning from department. Will that work? Yes, of course, there is no issue. But thing is, of course, you can watch daily what you can do. Weekdays session you have opted. You are a working student. I mean, you are a student in MTech, right? And you have morning session. You will have lectures, so you cannot attend weekdays. You are saying yes, that will also work. After returning home, you can watch recorded session. But thing is, you might get some doubts about those session, but sometimes means some days you need to attend live sessions also, right? Those doubts you can clear on Saturday Sunday, because Saturday Sunday we will be having industry expert. So weekdays, after returning from college, after lecture hall, you can just go through recorded session. So have a collected doubts and clear it on Saturday, Sunday from industry expert. That can be work. It can work for you. Clear? Or if you think I cannot afford extra time after lecture hall, I don't have enough time in weekdays, then you can shift to weekend batches in that case, only Saturday, Sundays. Right? But if you are available, if you are a non-working, if you don't have some additional condition, then I will suggest you best is to attend weekdays classes, right? Because you will go with a good pace and you will have some extra time. Clear everyone? Any doubts here in placement support and interview preparation? Any questions here? Any more questions? Regarding companies and what you said, so I will explain that also in last, right? Don't worry. Okay. So what will be the placement process overview? What is the overview of placement process? How it will work? The step one is complete your course, complete all your sessions, right? Attend all your live sessions, attend all your lab assignments and lab sessions. Do not miss any classes. Why? Because you are attending the live session or not, it will be recorded. We might not take any attendance from you, but see here, we know that who are attending sessions regularly and who are not. That kind of records we have. So don't worry about that. So regularly you should attend each and every session. Complete all your theory session assignments and lab assignment. The materials, the theoretical materials, the conceptual materials which is given to you, right? In the end of those material, you will have one question bank also, full of questions, so you can solve those assignment questions also, right? There are many questions, interview questions are there, and some assignment questions are also there in the end of your course material in PD advance. So that will also help you in building your interview questions and the conceptual questions also. Some lab questions are also given in those material for your practice. Company hiring I will explain you, Vignesh. Sir, I have opted for e-learning recorded session. Will I will be given placement support all along with the offline? See, one thing I'll tell you clearly, there is no difference between online and offline once it comes to placement or recruitment process. All will be treated as same. Once your course is completed, you will be added into one placement group, separate group. So there is no differentiation between online and offline in that group. So once you are there in that group means you will start getting those opportunities in that particular group. You will start applying those profiles, right? So there will be no difference in giving opportunities. So online will be given more or offline. But thing is, which mode is helpful if you ask me in preparation, not in giving the opportunities. I'm telling you which one is better in sense of preparation, helpful in preparation, that is offline mode. If you come in class regularly, you will be serious, face to face you are attending in front of what means you are attending trainer and you are seeing trainer, and you can ask immediately doubts in live sessions only, so you don't have to wait for next day, right? These are the advantages. Of course, for the obvious reason, this cannot be achieved in online modes, right? Of course, you can ask sessions, you can ask doubts in live sessions, but the advantage of offline mode is that they can ask doubts anytime they want, because weekdays trainers, lab trainers are available here, right? What about lab for e-learning? Like I said, for e-learning mode, labs will you are going to attend same live session if you are a non-working student, that is weekdays, right? If you are a working student, in that case, your lab session will be on Saturday, Sunday. So the like I said, live session will be common for both offline and online mode. There is no difference whether you choose online, whether you choose offline. You are attending from institute, not attending from institute, it does not matter, because session is common for both. If you are choosing weekdays, only lab session which is difference from weekdays is for weekend batch, that is Saturday, Sunday, for working students who cannot attend on weekdays. That lab session will be conducted separately on weekends, Saturdays and Sundays. Other than that, theory session and weekdays lab session is common for both online and offline mode. Recorded will be given to both online mode and offline mode students. Clear? Live recorded session will be available for many days, 15 to 20 days. Yes, sir. So it will be available till your course end. Each and every once, suppose today's session is over. So immediately what will happen? By evening, you will get recorded session. So this is how it will work. So till what time that recorded session will be available? Till your course ends. So till your course completes, those recorded sessions will be available. Maybe sometimes on request, the 10 days will be given more so that you can watch and you can miss. If you have missed something, you can cover up, right? So that kind of flexibility is also provided by us. Clear, everyone? Any questions? Any questions here? Okay. So what placement process we are following? First thing is attend your sessions, complete your course, complete your assignment regularly, don't miss any classes. Second is clear internal test. Once your course completes, you will have you not only completion of course, during the course also we will have what regular internal test for tracking the progress, right? And mock interviews. Once your course is in the end of completion, you will have mock interviews. So you should attend all these things. Interview preparation sessions will be given from last month onwards of your course, right? So that you can improve where you are lacking. Next is once you complete all the step 1, step 2, step 3, the last step, which is very important step, is that we will be adding you into one group where opportunities will be given to you, right? So based upon your eligibility, you can apply on those opportunities and you will start getting interview calls and hiring from hiring partners, which we are going to provide to you. Can you clear the above doubt? Which doubt, Rakesh? Which you
Hello, sir.
have given? Yes,
Hello, sir.
yes.
Good morning, sir. Sir,
Good morning.
if someone is passed out in 2013 in electrical background and around 6 years of experience in electrical core line, how was the
Mhm.
placement for him?
Okay, you are asking your pass out year is 2000,
13 in electrical
2013.
background. Yes.
Okay. So let me tell you
And
this.
sir,
Kindly
another thing,
explain.
sir, I have around 6 years of experience in electrical maintenance and electrical
What
design
is
as well.
what is that fixed?
6 years of experience in electrical maintenance in power plant in Lamco and in electrical design as well. So
Okay.
how will be the placement scenario for me and what I will do after this course?
And Rakesh, so you have two questions here. So first question he is asking, right? He is a 2013 pass out. So what about the job prospect? His question is what about the job prospect if he is a 2013 pass out? Second question he is asking that he is having an pass out with electrical subject and he is also having electrical subject experience. Okay, and I mean job experience in electrical design. So how this will
Yes, sir.
help in job prospect? So these two he has asked. So what about you are passed out in 2013 and you are electrical subject? It does not matter. I will tell you why. Because if you are from electrical, first I'll answer those who are from electrical background, right? Whether you have learned digital subject in your course, whether you have learned digital subject, whether you
Yes,
have
sir.
learned electronic subjects like
Yes, sir.
EDC, network theory, signal and
Yes, sir.
system,
Yes, sir.
right? So
Yes, sir.
electrical or electronics, if you observe, 60% of course or subject is same. 40% or I will say 30% difference is there between electrical and electronics. What is that? Some basic electrical machines, some power electronics is there as an elective in electronics also, right? So some 30% subject difference is there. But whether the core subject or basic subject is different, no. For electrical or electronics it is same. That is the reason. So companies will consider electrical student also as a VLSI design engineer, right? Provided that you are a trained candidate in physical design, trained candidate in VLSI subject. You should be trained. Only then only they will consider. If you are not trained as a fresher, as an electrical student, it might be difficult for you. Okay, this is the answer for electrical person. Now coming to the pass out year. If you are a 2013 pass out, plus you have a 7 years of experience, let us say, in some electrical subject, it does not matter. Okay, so you can still come into VLSI design, but the catch here with respect to the question 2, catch here is the VLSI design, you want to come into VLSI design industry, right? So you will be starting as a fresher only. This experience won't work here for you. So you will be thinking, I have a 7 years experience in electrical design. Whether it will be working in VLSI design? So answer is no. So they will treat you as a fresher in VLSI industry or semiconductor industry. So, okay. But yes, I'm not saying it is a waste what you have done in the 7 years experience. Of course, you have learned many things. Those learnings somehow or some other way, it will be helpful while you're working. Of course, you have developed some skills. It will not go in vain. But thing is, how industry will treat you, I'm telling you. Semiconductor industry will treat you as freshers, even though if you have a electrical 7 years, not only electrical, some people have work experience of 5 years, 4 years, 6 years in IT domain, maybe some computer science domain, maybe software, maybe cyber security. So these all experience will also not treated as experience in semiconductor industry. Will be treated as fresher only or trained fresher if you have a training. But thing is, you should have training in these cases if you have some past experiences in different domain. Anand sir, if experience is in PC, yes, like I said, so PCB design will also not be considered as experience in VLSI design, because VLSI design is nothing but a nanotechnology. Nano means what? 10 to the power minus 9. It is nothing but a nanotechnology. What is PCB? Printed circuit board, where you can see interconnects or not. Between two components, you are connecting some interconnects, right? You are drawing some interconnects. It is visible to your eye or not? Whether it is in nanoscale. So we are discussing here in VLSI about nanotechnology. So every concept gets completely too much complex and different. So that experience will also not be considered as experience in semiconductor design or nanotechnology industry. But yes, what you have learned in your experience, it will be helpful as a skill. That is your part. But the company will not treat as experience. Can it be helpful to jump to it? Yeah, like I said, it will be helpful to jump into VLSI, but thing is subjects are different, right? Like CMOS technology is there, right? Nanotechnology is there, how those things work. So those things you have to learn, and we will teach you here. We have a very sophisticated, very clean, and very time means very good course structure is here, right? We will complete everything on time. Don't worry about that. Basics, we'll start from basics. If you think like there will be some people who are having some gaps between pass out year, so they are passed out in some XYZ year and they have gap of 2 years, 3 years, 4 years of studies. They are working in some other domain or not working, right? For these kind of people, what will happen? They might have forgotten all those basics like digital CMOS. So that is the reason we are giving starting 2.5 months extra to cover basics for physical design. We will not cover all engineering subject. We'll only cover those basic subjects which is required in VLSI or particularly in physical design. Okay, so that you can have a brush up revision on those subjects, even though if you have a gap.
Just
Okay.
a small note. During this course structure, do we study about static timing analysis or clock
Your
cycle?
voice is not clear. Hello.
So during this
So
course
whoever's
structure,
speaking, yes, Mithilesh, you are speaking, right? You can write in chat box also. Your voice is not clear actually. Maybe due to network. During this course structure, do we study about SOC and STA? Yes, I will explain that also. Yes, we are going to cover STA, but not SOC, right? Before understanding SOC means system on chip. Before understanding system on chip, you need to understand block level design, right? System on chip concept is more advanced, right? For experienced people who are working for 3 to 4 years, 5 years experience. Those people will be learning about SOC, right? So first is if you are coming to physical design, it is a block level design. So that we are going to uh, help you in that, right? So we'll be working in the latest technology. Don't worry. In the deep submicron region only, we'll be working on 14 nanometer and 28 nanometer as a part of project. Now, many people here who are attending demo session, you might not aware of what is chip fabrication, what is chip designing. Maybe in graduation you might have learned about chip fabrication steps, right? How fabrication steps work and what is chip designing. See what it involves in chip fabrication, what it involves in design. Always first what comes? Design, right? What it involves? Designing a architecture, logic design, and having a physical implementation of that design. That is called as layout, right? You see, you build a house. Whether you start immediately building a house or first you draw the layout of that house. So if you go to purchase some flat, right, or some house, what that person will show you? They will show you the layout of those plots or flats, right or wrong. So that is what a physical implementation of layout, or it is a design, right? Not the actual thing. It is a design, right, of an integrated circuit. Now what will happen, what involves in chip fabrication? It is the manufacturing process, it is the manufacturing process of semiconductor chip design, which was designed, which we are calling as layout design, right? So which happens where? Which happens in physical, I mean those are called as fab labs, fabrication plants. Like what? Can you name any fabrication labs if you know? Fabrication labs where semiconductor chip designs are fabricated, right? What simulating tools will be provided? See, like that slide I have already covered, right? See, I have already told in course structure what tools we are going to use as a part of project work, right? Those are design compiler, ICC2, fusion compiler. These are called as not simulating tools. These are not simulating tools. These are called as EDA tools, electronic design automation tool. Whether this comes in back end or front end, it comes under back end, right? Where we are doing hardware designing. It is purely physical implementation of design, right? So PD is nothing but physical implementation of a logical design. Clear? So IC synopsis tools, licensed synopsis tools will be used. Yes, I was asking whether you any know the name of fabrication labs. or fabrication plant? Anyone? Fabrication plant, whether you know name right now, is there any job? Yes, it is there, Manoj. There are opportunities. Yes, please tell me. Have you heard about fabrication? Chip fabrication? Company name? No one? Online?
Yes, MC sir.
So what I'm asking here, have you heard about fabrication labs or fabrication companies?
Tata
Not
Electronics.
TSMC, Taiwan Semiconductor Manufacturing Company, right? It is located in Taiwan, right? So Taiwan itself holds 70% of fabrication market. Yes, Samsung, Intel, Global Foundries, fabrication labs. Whether they are designing the chips, whether they are designing any processor, any integrated circuit, yes or no? Whether fab labs are designing any integrated circuits? No, right? They are not designing any integrated circuits. What they are doing? The circuits which are already designed by some other company, their work is to fabricate on what? On semiconductor chips, right? What is that material which we are using for chip fabrication? Silicon. It is nothing but semiconductor, right? On those semiconductor wafers, whatever design which is designed already by some XYZ company, those will be coming into these fabrication lab, right? Which will be fabricated on silicon chips, semiconductor chips. Okay, so I will show you some few things also. So what is this? These are called as silicon wafers or semiconductor wafers. Silicon, these are nothing but silicon wafers. Do you see any circuit on this silicon wafer? So there are billions of circuit actually in this silicon. That is why we are calling it as nanotechnology, right? Why nano? It is 10 raised to minus 9 size smaller, right? Which is smaller than, whether you can see your hair, whether you can see your hair, you can see. Means it is visible to your naked eye. It is not a microscopic size. But whether you can see circuit, no. It means it is smaller than your hair also. Whether you can see coronavirus, you cannot see, right? What is the size of coronavirus? Hmm? You have checked or not? Anyone who can tell me size of? Everyone know or not this virus name? You might have done work from home college days, right? So what is the size of coronavirus, right? So you can see here in this picture, right? So here it is not given, right? So these are some virus sizes, right? You can see bacteria size is 2 micrometer, right? See, this is some virus which is 1.5 micrometer. Mimi virus is 400 nanometer, right? Zika virus is 45 nanometer. Paravirus is 18 to 28 nanometer. Similarly, if you see, COVID is also some size, right? So COVID size, coronavirus size is 100 nanometer size. Yes, 50 to 140 nanometer, Shivansh, correct. So it is having what? Approximately 50 to 100, or we can say like 50 to 200 micrometer of size, or 100 micrometer of size, 100 nanometer of size, sorry. So what is the size of COVID? 100, right? Approximately 100, we can say 100 to 200 nanometer is coronavirus size. So here in this institute, the project which you are going to handle, it will be on 14 nanometer or 28 nanometer. So what we have understood from here, hmm? Your semiconductor design is smaller in size than coronavirus. By what times? By 4 times, approximately 4 times, if it is 200 nanometer. Understood? It is that small. That is why we are calling this as nanotechnology. It is not visible from our naked eye. It is a microscopic size. Here, everyone. So these are what? These are called as silicon wafers. On these silicon wafers, fabrication process will happen. You can see these square pieces, right? In each silicon. Yes. So not only Qualcomm, so most of the major giant design companies like Broadcom, this Intel, all these are working, Qualcomm and all these are working in 3 nanometer project, 2 nanometer project, 5 nanometer project also, right? So if you see this wafer, you can see all these squares. What are these squares? These are one circuit, one design, one chip. You can see this image if you observe carefully. This is what? This is nothing but one chip. Similarly, there will be hundreds of chips in this one wafer, right? So each chip will have one complex design. Let's say a processor. If you check your phone, which processor you are using in your phone? What is the processor which you are using? Maybe Qualcomm based mobile processor, that is called as Snapdragon, right? Or maybe Helios, right? Or maybe ARM architecture, or maybe Samsung architectures, right? Exonis chips, right? Similarly, you might use MediaTek based processor. What is that? Dimensity, right? That processor name. So these are nothing but a processor design which is fabricated in each and every chip. So each silicon wafer will have multiple number of such chips, right? So each wafer will give us how many chips? Hundreds and two hundreds of processors. Let's say for an example, it is a processor design. So hundreds and 200 processors will get from each silicon wafer. How much silicon it is, how much costly we can say silicon, whether it is costly than gold or less costly? It is costly than gold or lesser costly than gold? Silicon material. Why lesser than gold? Why you think like that? Correct, absolutely correct. Good. So the silicon is nothing but extracted from sand, right? Which is abundant in nature. It is easily extractable and it is melted in form of silicon ingot. Silicon ingot is nothing but a cylindrical structure which will be sliced into silicon wafers. On the silicon wafers, then we will be starting, then we'll do the etching process. You know, fabrication steps process. So we'll have a etching, doping, chemical vaporization, decomposition process. All this process will be happen. Then we will be having the etching process through what? UV light, which will be passed through one lens. Then it will be cutting into circuits. It is a nanoscale fabrication process. Do our course will helpful in future, or should we work on FinFETs? See, FinFETs is not some big design technology, right? It is all based upon CMOS concept only. FinFET is just a structural change, nothing new device. Okay, if you ask me what is the difference between BJT based designs and CMOS based design, what is the difference? BJT is current driven and FETs are voltage driven devices. What is FinFETs? It is also voltage driven devices. Since it is also voltage driven devices, most of the concepts which we learn in CMOS logic, it applies for FinFET only. The only change is FinFET's structural change, nothing more than that. Now we are having multiple scalar planes also, right? What is that? Structural change. It is also voltage driven concept. What is the difference between front end and back end, and what is better for future? So yes. So one more question was there from Manoj. Do our course will be helpful in future? So helpful in future for whom? For the society or us? So there are two parts in this question, right? So for us, yes, it is helpful in this. I mean, for us also as a part of career growth. So there is a forecast you might have seen, right? So there is article. This is article from Economic Times. Okay, from manufacturing article is there. So what is the forecast? The Indian semiconductor market is expected to triple to 100 billion by 2032 by now. What is the current market? It is a $13 billions, right? It will reach to 100 billion by 100 billion means what? 1 trillion by 2032 means in almost right, in almost less than 10 years it will reach to triple the size of market what is present right now in India. So of course, if things are growing, opportunities, career growth will also grow in parallel, right? So with respect to our growth, so answer is yes. So growth is there, future is there in this prospect. What about society, right? What is there for society? That question you should ask, right or not? Because what you are giving to society as an engineer, that is also very important. So whatever technology, whatever electronic circuits you are working, if you observe carefully, now we are in the world of fully electronics, chip based design. Now you are seeing those cars which are having ADAS system. What is ADAS system? You know ADAS system? What is ADAS system in cars? Correct. So these are helping our cars to drive it in autopilot mode, right? So cars now getting very intelligent. They can judge where to take turns, whether the owner of that car or driver of that car is sleeping or awake. If the person is sleeping, what car will do? Car will immediately start flashing lights. It will slow down, it will move to first gear, and automatically it will take a side and it will stop there itself, and immediately it will call to emergency number also. Now That kind of features is also available. How this is all possible? Because of semiconductor chips, VLSI chips. We are still in phase of what, doing some R&D. We're still improving in more, in terms of better and better, right? We don't know what will happen in 10 years. It will become more stable in the sense. Now you're seeing EV vehicles also, right? EV vehicles also, what we are seeing nowadays in roads, we are seeing a lot of scooters, lot of EV cars, lot of cars from Mahindra, Tata, and these are all budget-friendly EV cars, right? We know Tesla also, which is right, overpriced, not for Indian, not affordable for the Indian market actually. But the affordability, if we talk, so Tata and Mahindra is providing a good EV vehicle. Even if you can see on roads also some EV vehicles nowadays, right? So in EVs also, so if we want to have a better battery management system, we require what? A semiconductor nanotechnology chip which can fit inside small space. What is the advantage of nanotechnology chips? It can fit into any small space. Now we have a bioengineering or in medical applications. Nowadays we are going to have operation. We are having some nanotech chips that can helpful in detecting cancer and neutralize that cancer, right? If there is a mutation in body, how to detect that mutation and how to neutralize that cancer. So now we are going to develop nanobots, right? Nanobots will have those intelligence which will be injected through a injection, a solution, like a fluid, with a fluid. It will be injected in your bloodstream itself. Those nanobots are going to found that mutation which is developing inside your body, and the cancerous cells will be neutralized. So that kind of research work is also, that level of research work is also going on, right? Now currently if we see the sonography or the we say EMR, right? What is that? MRI, we will say, right? All these machine works on what chips? Semiconductor chips only, right? You see medical, like dental, if you go for a dental operation or root canal treatment, so they will inject one camera and some stuff, right? All those are also working on semiconductor chips. Nowadays, they're having operation without surgery, right? You will be seeing some brain operation. Earlier days, if we used to see the brain surgery 10 to 20 years back, they used to drill the skull itself and then they used to remove the blood clot. Nowadays, it is not required to drill that skull. Without drilling the skull only, we can inject, we can some, there is kind of intelligent wiring system is there which can move according to the arteries, right? And it can remove those clots from heart, or we can do microsurgery, brain surgery. So we can insert wire inside them. So that is how things getting easier, right? Getting more possible, we can think more, we can expect more, right? So these are some application. You can think the extent, you can think where we can go, right? Nowadays we are having smartphone, we are having earbuds, we are having smart battery system, wireless battery system. Nowadays we are having extremely intelligent guided missiles. We are seeing fifth generation aircraft, sixth generation aircraft. How these are possible? We are seeing ultimate intelligent drones, UAV, stealth mode drones are also now coming from DRDOs, right? How these are possible? Because of nanotechnology, semiconductor chips only, right? Because those chips can fit into small size. Here, everyone. But thing is, the technology node can be different. Okay, it's not necessary that all these chips are designed in 5 nanometer or 14 nanometer, 28 nanometer. And this is also true that all these smaller technology nodes are not the best, right? Nothing is best, nothing is worst. It's not like 180 nanometer technology node is worst. It is the bigger size. No, it is the most robust one. If you want to use some chip, if you want to design some chip for military grade purposes, like military grade laptop, military grade tankers, right? You will definitely require which technology node? Higher technology node, because it has more robustness, right? Okay, we'll take some question. So what is the difference between front end and back end? So the overall conclusion is what? So with respect to society, with respect to our career growth, both will be growing in next 10 years. That is the forecast. What economic times or what economic people will say. What is the difference between front end and back end, and what is better for future? See, this is better or that is better, we cannot say. Front end or back end, all are part of VLSI design cycle. So front end, what is the difference here means? So front end, right? It is mostly what is back end. I will explain this later on also. So major difference is back end is based upon physical implementation. The actual hardware design starts from back end, whereas front end is mostly logical talking, right? Logical design, RTL design, behavioral modeling design codes, right? It all are what? Logical talking, more logical talking. We are not talking about width and size of chip there. We are not talking about what will be the electrical properties. Front end, we don't care about electrical properties. The all physical, the real parameters is not discussed in front end, right? Once it comes to back end, everything's real time situation you will see. So it is not necessary whatever RTL design we are designing in front end, it will pass in back end. Why? Because in back end size comes into play, right? Electrical properties, resistivity, everything will come into play. The IR drop, voltage drop will also be there, right? Static, electrostatic discharge will also come into play. The real-time design is quite practical. The real-time environment situation will also come into play into chips. Suppose you take your phone, you have taken your phone into some snow area, Siberia, right, where the temperature goes to minus 8 degrees Celsius, minus 16 degrees Celsius, where you just throw a water and it will get freeze up, right? That kind of temperature is there. Whether your phone will work there, it should work, right? Ideally it should work. Such kind of chips you should develop. If you take your mobile phones into high temperature in Saudi Arabia, in Arabs, right, or in desert where the in daytime temperature goes to 50 or 60 degrees Celsius, 55 degrees Celsius, that time also your chips, your mobile phones should work. I'm giving one example, mobile phone like that, electronic circuits. So it should work fine, right? It should work good. Similarly, if you go into humid climate, you go into rainy climate like Meghalaya, your phone should work properly in humid climates also. Understood? So all those depends on what? Real time practical scenario, real time parameters, real time hardware design. It is in back end, right? So front end is all about logical talking. In major aspect, I am explaining the difference here. I'll explain more in technical aspect also. Okay. So yes. So chip fabrication versus chip designing. Chip fabrication versus chip designing. Who does it, right? So like I said, chip fabrication is done by fabrication labs. Those are TSMs, those are called as foundries. TSMC is from Taiwan, Global Foundries is from US, right? Similarly we have IDM. So IDM is nothing but which are having fabrication labs as well as design unit also. So Intel and Samsung are such examples. So Intel, they are designing the chips as well as they're fabricating their own chips. They are not sending it to Taiwan because they have complete facility. From what? Full VLSI cycle, they have that facility from designing to fabrication. Similarly, Samsung also have its own design to fabrication unit. Right? It does not needs to send their design to TSMC for fabrication. Those are IDMs. Right? CIMIC is a Chinese-based fabrication company. Okay. Fabless companies. What does fabless companies means? The companies which only design the chips does not have any fabrication unit, does not have any manufacturing unit. They are not manufacturers of chips. They are the designers of chips, which will be ultimately going for fabrication. Fabrication on what? Silicon wafer. Clear? So what are those fabless companies? Those are Qualcomm, AMD, Nvidia, Broadcom, right? Any other company you can tell me? MediaTek, right? Any other? So yes, Snapdragon is from Qualcomm. E-Info Chip also developing some products. Yes, you can say it is a design company. So there are many companies, many design companies. Some are startups, some are well established, some are 20 years old, some are 40 years old. Exonos. Yes, there are many design companies. So what are key tools which are used in fabrication, chip fabrication? So tools like caliber, T-cent and PVS. These tools are used in chip fabrication, right? What are tools, EDA tools used in chip designing? So Synopsys ICC tool, Innovus from Cadence, Fusion Compiler. These tools are used for designing your nanotechnology chips, right? Understood what is the size of that chip? So it cannot be designed on pen and paper mode. Understood why we are using EDA tools? We are using EDA tools because the scale of designing is in nanotechnology, which is smaller than coronavirus. So what is the process? What is process? The process in fabrication, like we know that it is photolithography, etching, doping, and deposition. In major terms, we are saying this is the just major terms we are saying that the process is in these four parts. But it is more sophisticated and complex steps are there, right? Which you will understand if you go as a fabrication engineer. They are not designer; they're just fabrication engineer. So in that case, so if you have done PCBs, right, in your graduation, you have done PCB designing or not as a lab experiment. You haven't developed any circuit, not VLSI circuit, just normal circuit. You haven't seen PCB? You know PCB or not? What is PCB? Printed circuit board, right? Where components are mounted. There will be one copper interconnect which is connecting all through those component. There will be power system and then voltage state change. For that we are adding what transformers to have DC to AC. We are having rectifiers, all those components. We have done or not? Then we will have sensors, connecting sensors, giving some inputs, some buttons, right? Kind of some kind of mini project or something you might have fabricated or not. PCB fabrication, those are called as PCB fabrication, not VLSI fabrication, right? So how you have done? So you have designed one circuit on pen and paper, right? Paper, and now you want a PCB for that. What you will do? You will bring one copper clad, right? What, how you will design in PCB? You will bring one copper clad, right? This is called as copper clad, right or wrong? You will bring one copper clad, it is full of, this is copper. Next what you will do? What is the next step? You will draw circuit or not, or you will print circuit, right? It depends. So you can manually draw the network. These there will be components, or you can what you can do? You can print these circuits or not. Understood what I am saying? This is nothing but circuit, the network. So once you have drawn it, right? Why we are drawing it? We'll draw with some marker, or you might print, which is printed on page. We are printing one black color interconnect network, right? Why we are drawing it? Those will be acting like a photoresist. Photoresist means which blocks photons. What is photons? What is photons? Photons are the light parameter, right? When there is a light, right? It projects what? Photons, units, right? So it resists what? Photons, light. So what light? Suppose, so how we are fabricating this, right? So we have drawn photoresist on this copper clad. Now what step comes? What is the next steps? What is the next step called as? Etching, right? What is etching? Etching means taking something off, right? Etching means taking something off. What something? Wherever photoresist is not applied, that will be ripped off, that will be taken off, right? Only that part will be remaining of copper where photoresist is applied. Now how this work? Under some catalyst or under some, right, component. What is that component? UV light. We require what? UV light plus ferrichloride solution, right? We required ferrichloride solution or not? So under this combination, you bring this circuit which has a photoresist and you dip that in solution. What will happen? Correct. So the remaining part of copper where photoresist is not applied, those will be washed off in this solution or not, right? So now you erase this photoresist. Now remove this photoresist. Now what you will see? What you will see? Only network, copper network, right? Wherever you have drawn the network, right? Wherever you have drawn the circuit, right or wrong? This is how we are drawing what? Fabricating what? Network on print. That is why it is called as what? Printed circuit board. We are printing the circuit on one copper board, right? Now you have drawn this. Next step is mounting the devices. Next is what? Mounting the devices, right or wrong? You're mounting the devices or not? Devices like what? Suppose you are going to connect some LED, right? Some LED, maybe some power supply, right? Some power management system you are connecting, maybe some capacitor. So you are going to mount devices, mount some component according to what circuit, which according to what network which you have drawn. So this will complete what? Your circuit. Not only that, of course, we are going to do some testing also on PCB. Whether what testing, like major testing is continuity testing, breakage testing, IR drop testing. All those testing you will do or not. If you have done PCB, if you have a mini project or some final project, you might know all these steps, right? Drawing same analogy to this, similar things happens in semiconductor, or I will say silicon chip fabrication steps, right? What happens here? So the base is what is the base here? Base is called as silicon wafer, right? I have shown you, right? It is a silicon wafer. Base is silicon wafer. On this silicon wafer, what we are doing? We are doing all those fabrication process, right? Now what you will do? You will now the complete thing is a silicon, right? Now the circuit is made up of what? CMOS logic or not, right? So this is a circuit diagram of CMOS inverter, right or wrong? This is a circuit diagram of CMOS inverter. But physically, how any MOSFET looks like, we know? We know or not? Yes, we know. The physical MOSFET looks like there will be one silicon substrate, and then we will have doping. Doping with, suppose this is N-type MOSFET, then what we will dope with? Right? N plus, right? We will be doping with N-type material. This is what? P-type, which is nothing but substrate, your base. In this P-type material, we are doping with N plus material. Then we will have silicon dioxide layer. Then we will have polysilicon layer. And then we will connect with interconnects or not, to the terminals, gate, drain and source. Understood? This is a cross sectional look, right? This is a cross sectional view of what? MOSFET, actual MOSFET device. What is this? This MOSFET is a symbolic representation of MOSFET. Understood? The physical representation of MOSFET, the actual device after fabrication will look like this. Right? Now this thing has to be fabricated on silicon. How it will work? First thing, so this complete thing, let's say it is a substrate, right? It is a substrate, P sub. By default, it is a naturally, it is a P sub only, P type only. Now, you are going to add some impurities or not to get what? N type or P type material in order to have the device logic, right? Now, to have one NMOS, let's say I want only one NMOS here, right? Now, to a single NMOS, this is complete P substrate. What you will do? You will first etch this, right? You will do the etching of this particular material. So you will be etching off that particular material, and you will be doping, or instead of etching, what you will do, you'll be doping with the impurities so that it becomes what? N type material. Now thing is, this complete thing is silicon, right? Whether we want poly throughout like this, we don't want poly throughout on top of this substrate, right? We want poly only for this particular region. Yes or no? So what we will do, we need to etch off this region or not. We need to similar, I'm drawing same analogy here what I have discussed in PCB. We will be etching off this region. After etching off, so how we are etching off? First we need to apply one photoresist, right? Then what will happen? We'll take one lens, one mask, and UV light will be passed through this mask, lens, right? And then it will fall on top of this substrate. What will happen? It will etch off this, right, this area, and it will keep the polysilicon here. So like that, each, so this is just layers, right? This is a substrate layer, this is a diffusion layer, this is a silicon dioxide layer, this is a poly layer. So each and every layer, layer by layer, it is getting fabricated. This is about one device, right? Still we can call it as circuit. Yes or no? We cannot call it as circuit unless and until this particular device starts connecting to some meaningful device. Then we can say that it is a meaningful circuit, right? Till now it is just a terminals. Likewise, we will be fabricating many MOSFETs, NMOS, PMOS. Based upon CMOS logic, we are going to fabricate many devices in our silicon wafer in that particular area. This is one chip design. Okay, now those things should be connected or not? Yes, it should be connected through metal layers. Those are interconnects. See, in your home also there you have many appliances. Those are connected to electrical wiring, copper wiring or not. Metal connects or not. Copper is nothing but metal. Similarly, these are MOSFET or NMOS devices or some devices. Those will be connected through interconnects, metal layers, right? So once device is fabricated, on top of that we'll have metal layers which will be getting connected. Clear how fabrication works? So whether we are thinking about anything about design, no, we are not talking about design here. We are talking about manufacturing process, right? So whatever designer designs the design, right, circuit, that will be manufactured, that will be fabricated where? In fabrication lab. Clear everyone? So it will be fabricated where? In fabrication lab. The design which is designed using EDA tools. Okay. So these are the process. What is the process in designing? So first is RTL coding, a Verilog code, which is called as HDL code. What is HDL code? It is a hardware description language. How different HDL codes are from C language? The C language is completely based upon logical high level language, right? We are not having anything related to electronics or electrical properties in those codes. But where it comes to hardware description language, we are having information about logical gates while writing that code. Hardware description language like Verilog code or VHDL code is nothing but a code of circuit, right? It is nothing but a circuit design itself, right? Depends on what modeling style we are picking up. If you are picking behavioral modeling style, then we will only define what behavioral logic. Gates are not required there. If you are choosing data flow model, then maybe the Boolean expression needs to be defined for that particular logic. If you are choosing gate level designing model in Verilog code, or we call it a structural code, in that case we need to define each and every gate. So what does this mean? So suppose I will say, so mux 2 cross 1 mux. How many inputs and how many outputs 2 cross 1 mux has? Two inputs, one output. Is it correct, everyone? Online? Two inputs, one output. Yes, online. How many inputs and how many outputs a 2 cross 1 mux has? Online students?
Two
So
inputs,
how
one
many
select
inputs?
line.
So not two, right? It requires total three inputs, right? So I0, I1 and select line. So it requires three inputs, one output, right? Now, how you can realize this? In what ways you can define this circuit? So you can write RTL code, right or wrong? You can write one RTL code. So RTL code can be written in different ways: behaviorals, data flow, and structural. If you want to write in behavioral, how you can write it? You have to write the behavior of 2:1 marks. What is the behavior of 2:1 marks? So behavior is always based upon what inputs are provided to that particular system. Let's say I have one system, it is X. Now how this system is going to behave, it is completely depends on input or not, right? What inputs are given to this particular system. Now suppose I have one system, right? So there is a person. Now you go to this person and give him some inputs. What inputs? So you give him some gift, right? You give some rasgulla or gulab jamun, some sweets you give him. What he will do? He will throw on your face. Hmm? He will thank you, right? That you have given him some sweets. He will be happy. So what is that? That is nothing but his output. What is his output? He'll be happy, right? He'll be thanking you. So that is nothing but his behavior or not. You will call it as behavior or not. Behavior depends on what? Inputs. What inputs you give, respective to that, you will get outputs. Now you go to same person and you go and give him 5 slaps, right? Now what will be the behavior? What will be the output? Hmm? He might hit you 10 slaps, right? Or he might run away if he's kid, right? 6, 7, 8 years. Or if he's a bodybuilder, right? A martial artist, he will show you stars, right? So based upon what inputs we are giving, the system will behave accordingly, right? Similarly, so if you want to write the code in behavioral model, you should understand the behavior of the device. So what is the behavior? How the system is behaving based upon inputs. What are all possible inputs which can be given? So possible inputs is 2 to the power n, right? What are the number of inputs? 2 to the power 3. What are the possible inputs? 16, right? 16 or right? 8. 8. So total number of possible inputs are 8. Now for all these possible inputs, whether the system will give same outputs, like here we have given 2 inputs, whether system has given same outputs? No, right? It depends on inputs, right? So for all these 8 possible inputs, might be give same inputs, might not give same, might give same outputs, might not give same outputs, right? What does this mean? It means, suppose you have given kaju katli here in one input and another input you have given gulab jamun, right? In both cases the person will give same output or not, right? Or in gulab jamun he does not like, he'll throw on your face and he'll eat kaju katli. It will not happen like that. Behavior will be same only in both the inputs. Similarly, in these 8 possible input, of course some inputs will give you same outputs, right? Understood? Now to write the behavior, to understand the behavior, you should have knowledge on Boolean expression also and how it is behaving. It is behaving and controlled by what? Select line. So if you choose s equals 0, right? If you give input s as 0, so output will be, right? Which output will be taken? Which input will be considered? I0 will be taken into an account. Else means what? Else the reverse is true, like s equals 1. In that case, y will be I1, right? Completed. That's all. We have written what? Logic. Logic of this. Whether we are defining any gate here, any gate, and gate, nor gate, anything you are finding in this code? No. This is why it is called as behavioral model code. Behavioral model, RTL code, Verilog code. There is no gate information. There is no electrical information here. Wait, bring charger. You can take 5-10 minutes break and then we'll resume. Yes, we'll resume from here. So we're discussing about how these codes will be written, right? So coming back to that one. So in this way, you can write the behavior of any logical device. Now, there is no gate, right? There is no gate information. How to get that gate information? Because ultimately, what will be fabricated? What we have discussed just now, that ultimately devices will be fabricated on silicon chips, silicon wafers. Devices will be manufactured. Whether you see any device information in this design, in this MUX code, right? No device information. So device means what? These devices, the MUX device is nothing but a circuit using what? Logical gates. So how many logical gates are required to design a 2 cross 1 MUX? How many logical gates are required? Primitive gates, how many required? Cross 1 MUX can be designed using how many logical gates? Everyone online? How many and how many are how many other logic gates, right? So we require 2 and, right or wrong? 2 and or not? 1 or, right? 1 inverter, right? 1 or 2 and 1 inverter. This is nothing but select line I0, I1 and this is output. This is nothing but 2 cross 1 mux using logical gate. Now the same behavior code can be written in what? Data flow or gate level netlist. If you want to write the gate level netlist, you can write the code for this also. So code means what? You have to write gate information. I require one and, second and, one or, one inverter. Now I can write the connection or not. This and one is connected to what pins? I0 and S0 bar, right? These pins it is connected, and output pin is connected to input pin of, or let's say this is W1, W2. So like that you have to define the connections, how it is connected. So this is nothing but, this is also 2 cross 1 mux using gate level or gate level modeling. Okay. So now still whether this design can be passed to fabrication lab, whether we can pass this design to fabrication lab, yes or no? Yes or no? Whether, see, if this design information, if I get to fabrication lab, whether they are able to fabricate it, answer is yes. No, sorry, answer is no, right? Why no? Because just now I explained in fabrication, it is fabricating in any devices, MOSFETs, right? It is using MOSFETs for circuit designing, using what? Layer fabrication. Layer by layer it is fabricating. It means, do you see any information on substrate? Do you see any information on poly? Do you see any information of metal layers? What metal layer we are using? What is the diffusion layer? There are no information. There are no such information on mask. So how fabrication lab will fabricate? So answer is no, right? Then this design is also not right. Then next, what you think? Then we should have transistor design, you should think, right? What you will be thinking, that logical design cannot be realized in manufacturing process. What we require? Transistor based design. Now you will be thinking about this particular and requires how many transistors? See, ultimately on silicon wafer, the transistors are fabricated or not, MOSFETs, layer by layer, what I have explained just now, right? So how many transistors required? How many transistors required for AND? If I am using CMOS logic, You might have done realization, right? So if I have a CMOS logic, CMOS inverter, right, like this. So using this CMOS logic, how many transistors are required to realize, and can anyone answer this? How many for or and how many for inverter? Total how many transistors? Then answer that also. Total how many transistors required for mux 2 cross 1? Yes, anyone? Okay. Anyone who wants to try, who wants to answer? See, there is no harm in answering wrong. Okay, if you don't know, it is fine. We are here to help you. This is not, see, one thing, get it very clear. I don't know how many are latest. 12. Huh? Okay, we'll see. See, one thing, make it very clear. This is not a college, right? This is not some university where you should get afraid of professor, right? Professor, here there is no professor. Here we have trainers, we have industry experts who are here to help you. So whatever your doubts are there, whatever your confusion is there, you can ask directly to us, right? We are here to help you such that you become stronger in subject so that you can clear the recruitment process. Okay. So do we require 6, right? How many? Okay. And each gate need 4, total 12. Okay. So 6, you are saying 6 transistors are required for AND, right? How many for NAND? How many for NAND? So if I want to realize NAND, which is the inversion of AND, how many transistors are required? Using CMOS logic? 4 or not? You might have done this in graduation. Realization using CMOS logic. It was there, right? Then why not answering? All basics. So okay, fine. Even though if you are not able to recall it, we are here to help it. We have CMOS subject in PD basics where you will get all those brush up and revision. You don't have to worry about it, even if you are not able to recall it. So for NAND it is 4 transistors if you are using CMOS logic. For AND it is 6. Okay, 2 extra because we are using inversion, right? Inversion of NAND, 4 plus 2, that we will get as 6. So 6 here, 6 here. Inverter needs 2 and OR needs 6. Total how many? 20. So we can see that by discount we require what, at least what, 20 transistors, right? 20 transistor to get what, 2 cross 1 mux. Now using 20 transistor, you can replace the CMOS logic with respective logic gates or not, right? And you can have complete, not gate design. Now you are having transistor based design. Transistor based design using what? FETs. Using transistor, now you are having complete mux 2 cross 1, right? Like this. Now the transistor design is present inside your mux 2 cross 1. Whether we can send this data to Fab Lab, whether we can send this design data to Fab Lab, transistor design, yes or no? Hmm? Why yes? Whether we have any poly layer information, whether we have diffusion layer information, whether we have any substrate information, whether we have length and width information of device, I am saying that inverter requires PMOS and NMOS, right? So let's say there is one inverter here using PMOS and NMOS. Whether any information is there on length and width for this particular transistor, whether it is physically present, answer is no. So we cannot send this to fabrication lab. It is still a what, a transistor level design without physical attributes, without physical implementation. So what is the next step once your transistor design is ready, right? The schematic, it is nothing but a schematic. or circuit, right? What is the next step? This design should be converted into physical design or physical implementation of that particular design. That stage is called as physical design stage. Clear, everyone? From where we have started? We have started from RTL code, right? Which is behavioral in nature. This must be converted. This the converting process is called as RTL synthesis, right? RTL synthesis will give you gate level netlist. Okay, gate level netlist, where you will have gate information in the code. It is nothing but gate level netlist, which is converted where in RTL synthesis. After that, it should have some logical meaning, transistor based meaning, right? Then you will have physical. See, there are some verification steps also. See, having just a behavioral design does not work, right? You need to verify this design also. So there comes design verification stage, right? So that is also front end. Till this point, till before synthesis point, everything is what? Logical and front end part. Okay. Now we are in physical design, right? So in physical design, what we are having? We are having layouts. Layout of what? Let's say this is a inverter, right? PMOS, NMOS. This is nothing but a inverter layout which has proper, what is this? Width and length, right? Now, even you are having what? Channel length also. This is channel length. This is not complete length. This is channel length, right? Now, the spacing, what will be the spacing between this poly? This is nothing but poly layer, diffusion layer. What I am drawing, if I want to draw the NMOS, what I will do? This is diffusion layer, this is poly, right? Then if it is a PMOS, I will also require what? NWell, right? So this is what view? Cross-sectional view, side view or top view of device? It is a top view. What is the corresponding cross-sectional view? Hmm? What is the corresponding cross-sectional view? Suppose this is a substrate. This is a cross-sectional view. So here we are having n plus n plus. This is gate, right? Oxide and gate. This is what? Cross-sectional view. This is top view. If the same thing, if you see from top, what you will see? See from top, you will see this diagram or not, this design or not. So it is nothing but the top view of actual physical MOSFET, right? Actual physical MOSFET practically present, physically present, right? It is now more logical now. Now the MOSFET itself is present using respective silicon layers. That is what? Substrate, diffusion layer, poly, right? And this is channel. Everything is present physically now all this info, this is just for inverter. Think about complete processor circuit or some big complex circuit. Now those are having what? Multiple number of billions of transistors or not? Billions of such transistors required for one chip design or not? Am I right? One billions of transistors are required for one chip design, because inverters and NOR or which will be used to develop a mux will be used to develop a 4:1 mux, 8:1 mux, full adder, 32-bit full adder, 64-bit full adder. Means what is the difference between 32 and 64-bit? It means 64-bit requires more transistors, more devices, more hardware. It means it requires more area also, right? If your design is small, let's say just mux only, it requires very small area. It does not require much area. If you're designing a processor design, which requires lot of logics, lot of devices, it requires more area compared to this or not. So area will increase, right? With respect to complexity of design, complexity of count of transistors, right? So from this point, one more point comes up, right? That is called as Moore's law. What is Moore's law? Every 6 months or every 2 years or every 1.5 years? You know, right? I assume that you know it, but not able to recall. I'll understand like this. So Moore's law is nothing but for every 1.5 years to 2 years. So technology size will shrink, right? What is technology size? What is technology size? Like I said, technology size will shrink by how many times? 1.5 to 2 times, right? So what is this technology and what is this shrinking? Technology size means it is nothing but technology size or technology node. It is nothing but called as channel length. What is channel length? So we have seen MOSFET, right? One transistor, diffusion layer, right? This length is nothing but called as, this is oxide, this is poly. This length is called as channel length, right? Now, if the channel length is less, let's say short channel, what will happen? So for that, we should understand short channel effect, right? This where we will learn in CMOS basics. Okay, what will happen if it is a short channel? What will happen if it is a long channel? How device will work? How its constraints will change? The basic constraints are PPA, right? Performance, power and area. So if this channel length changes, how it will affect performance, speed or delay, how it will affect, how it will affect your power, how it will affect your area, right? If technology node is shrinking, everything will get shrinked or not. Size, complete size of layout of this particular MOSFET will be smaller, right? So smaller means what? If I use same area, right? Now my technology node here is 28 nanometer, here 14 nanometer, which can accommodate more count of transistors out of 1 and 2, which can accommodate more count of transistors, 1 or 2. In one, I'm using 14 nanometer technology node transistor. It means I'm using only those transistor which has channel length of 14 nanometer. In second, I'm using only those transistors which are having channel length of 28 nanometer. Now, by this explanation, what you understand, that which area, one or two, both area are same, area is same here, there is no difference in area. So which one will accommodate more transistor, which one will be having more transistor count in one or two? One or two? Why two? One, right? Not two. Why one? Because of feature size is smaller, right? Now if you see a Moore's law, right? Nowadays Moore's law does not applies. Okay, let me, still I will show you one. Yes, channel length is small, so everything will change, size will change. So doubles every 2 years means what? Doubling of transistor count. So this is a 125 years this is a 125 years plot of Moore's law. If you see, there are many transistors during the duration, right? 1900s to 1955, right? You can see there are some Apple based chips, Apple based technology nodes, right? You will see Pentium PCs. You have heard about Pentium? Pentium processors, Pentium 1, Pentium 2, 3, 4. then we have dual core, then we have quad core, then nowadays we are having what, octa core, 16 core processors, CPUs. So these blue color ones are Intel processors. Okay, no, not Intel. Some are IBM also. So let me see here. Okay, these are all NVIDIA and these things. You can see Dell, XPS, GTX. All these are what? Some names, some processor names, integrated circuit names. Okay. So what is happening? Transistor size. You can see on the left side, calculation per constant dot. Okay, this is something else. Wait, I'll show you different plot. We can take things. Yes, you can see here with these years what is happening. So you might have had 8086 processors or not. 8085, 8086 microcontroller, microprocessor. All those are developed using what? Transistors only, right? So earlier with this technology means what was the size, right? What is the transistor per die count? It was 1000. Then transistor count is increasing 4000 per die, means area is fixed here, area is not changing. What is changing? With yes, transistor count is changing. Now if you see, there are Pentium processors from Intel, Pentium 2, 3, 4, right? Nowadays we are having dual core also, we are having quad core also, we are having what, i3 is nothing but what, dual core, right? After i3 we have i5 also, we have i7 also. i7 is having how many processors, I mean how many cores? So it is a multi-core processors, right? So it means what? It means the transistor count has been drastically increased, gradually increased. That is what Moore's law states. Understood everyone what Moore's law states? So why transistor count is increasing? What is the reason? Because of technology node channel length is shrinking. Clear? Shrinking by what times? 1.5 to 2 times. That was, this law existed till last, before 10 years. Nowadays it does not exist. We do not follow this Moore's law because nowadays every 6 months also now technology size, 6 months, not 6 months, 1 year approximately technology size will change, but not by 2 times or 1.5 times. Okay, so that is what Moore's law says. Understood everyone, right? So that is what we are doing here in physical design. Now we have a layout of one device. Now how these devices, now this can be called as standard cells. Now how these devices can be used, these are just layouts. I'm just drawing the exterior of layout, right? So these are just layouts. Now how these can be connected? Based upon that, what will happen? We'll get one circuit or not, right? One circuit we will get. Now this circuit, the complete circuit, the graphical circuit, a physical design circuit will be sent to what? Fabrication lab for fabrication. Now to achieve that physical design circuit, there is separate process, there is separate flow, that also we will see, right? Now that file which we are sending to fabrication lab is called as GDS2 file, graphical design file, right? So what is GDS2 file? What is GDS2 file? Right? It is a graphic data system file, GDS2. So it is nothing but a standard file format for chip storage, right? A device storage, which has only physical information, like what? Layering. So it is a non-readable file. So first of all, it is a binary bin file, right? You cannot read it, but still I'm telling what kind of information is stored in binary format, right? The information is purely physical information, like which mask layer is used, right? What is the size, right? What are the coordinates in that particular area where device is placed. The coordinates will also be given, used to store the final IC layout before fabrication, right? Foundries use these GDS2 files to manufacture semiconductor chips. That's what we have discussed. Contains all circuit layers, including geometries defining chip structures, right? Connections needed for this IC functionality. So this is just one inverter. Suppose you are designing some complex design, which will have many inverters, thousands of inverters, right around 20,000 inverters. It may be there will be present. Maybe buffers will also present 20, 30,000. Then and or these logics will also present in thousands, right? So each and is developed by how many transistors? Using CMOS logic, 6 transistors. So likewise we need 6 for particular one and. So if there are 1000 and, how many transistor will be there? 6 into 1000 and. So how many total transistors? 6000 transistors are required. So the design complexity increases. With that, what increases? Transistor count will increase. Device count will increase. Now, this device is placed here. It means what? 6000 will be placed somewhat near to each other. Suppose there is a 12,000 transistor. You require some extra area or not? It will expand or not? So area will not remain same. If design becomes complex with transistor count, area will also increase. So in physical design, it is very important to focus on area, timing, and what is the complexity, right? Now we are also in the generation of low power devices, right? So so we will say that those are application specific integrated circuit. Why we are saying application specific? Because those chips are only meant for certain applications, right? Like if you are using earbuds, wireless earbuds, so those, what is the application for that? Taking up calls, talking and listening to music or something. So it is all related with audio facility, right? Better audio facility. So application is very much specific there. If you are seeing washing machine nowadays, we are having 6 sense washing machine, right? Nowadays those washing machine is also having what? Chips, right? Those are very smart chips. So application is specific. That washing machine chip cannot do the computer work. That washing machine chips cannot make help you in calling some person, right? So application is defined and fixed there. It is specified. Now this AC is also having inverter and chips also to make it smart. So that chip is very much specified for that particular air condition. It will not help you to call some person. It will not help you to create some ADAS system, right? So that chip is pretty much defined there. So those kind of chips are called as ASIC chips, application specific integrated circuit chips. Now these can be segregated into different types: full custom, semi custom, and programmable chips. Programmable chips. Full custom are those chips which are designed from scratch, that is transistor. Each and everything is designed from transistors. We are not talking about and or here. Everything is designed using transistor. In semi-custom, the basic level of abstraction of design is standard cells. Means using this transistor in full custom itself, I have developed mux, I have developed and I have developed full adder, I have developed full subtractor, right? All these I have developed here. So those I have already standardized. Standardized means its height, its width, right? What are the electrical parameters like delay, power, timing, and electrical parameters like power, right? What is the supply required? Everything is defined for these standard cell libraries. That is why we are calling it as standard cell libraries. Now I will take it like a library into semi-custom based chips. Now here I don't want transistor information. I don't need to design the circuit from transistor level. What I will do, I will use standard cells, right, which is ready made, and I'll connect it to get a bigger circuit. Understood? Suppose I want to get a 4 cross 1 mux, 4 cross 1 mux, right? Why I need to design from transistor level when I have already 2 cross 1 mux? I will pick this 2 cross 1 mux, I'll place it 3 times, I will connect it. So I'll get what? 4 cross 1 mux using 3 2 cross 1 mux. This is helping here, right? It is like a, you might have ate, many times you have ate what? Maggie. You have ate Maggie or not? Right? And your mother will also sometimes cooks noodles, right? Not Maggie. So some noodles, some local market, she will bring some noodles and she will add her own masala, increase spices, ingredients, right? Now what is the difference here between that and this one? So Maggi masala is nothing but a ready-made masala. It is standardized. If you purchase two Maggi packets and take two masala out of those packets and compare those masala, taste it, whether you will see the difference between those taste. So Maggi masala taste will be same only in those two packets. Why? Because during manufacturing, the taste was standardized. So you purchase hundreds of Maggi masala packet also, taste will be same. But when mother cooks, right? Today, tomorrow, or maybe next week, whether taste will be exactly same, sometimes will be changing, right? Sometimes salt will be more, sometimes spices will be more, sometimes different spices will also change. That is what? Full custom. So full customization, right? Mother is doing what? Every time experimenting, full customization. That is full custom, right? And Maggie is nothing but semi-custom. We are not doing customization from scratch. We are having ready-made masala that is called as standard cell library. We are taking exactly same ready-made masala and just dropping it and having a 2 minutes noodle, right? But never it will cook in 2 minutes. We know that. That is marketing claim, but it takes 4 5 minutes. Okay. Yes. So understood clearly what is semi-custom and what is full custom here. So what is programmable chips? Right? Programmable chips are those chips, even though the chip is fabricated, still there is a scope of reprogramming it to have a different purpose, to meet a different purpose. What does this mean? Suppose you have worked with APJ Abdul Kalam and you have designed one missile, right? Now you want to use that missile against some country to defend yourself. Now you have launched that missile to some other country. Now that country has already surrendered to you in the middle of what you have launched, right? Your missile is in middle of air and now that country has already surrendered. Whether you can call your rocket back to home, right? Is that feature available? Yes, in some rockets it is available, not all rockets. Those are called as guided missile. You can guide it, right? So how this feature is available? It is available because of programmable circuits or programmable chips, right? One more example is FPGA. What is FPGA? Field Programmable Gate Array, right? So you might have seen FPGA board also, right? In that you will have FPGA chip. So I don't know you have worked with FPGA or not, but FPGA can be reprogrammed n number of times, right? Suppose I want mux design in my FPGA. Yes, you can have mux, you can dump that code and you can have mux hardware, right? It will have gate arrays. So those are called as LUTs, right? So that can be possible here. Suppose you don't want mux, you want ALU design in your FPGA. Yes, that is also possible in FPGA. You can reprogram and have ALUs, right? So this is the advantage of, see, nothing is bad, nothing is worst, and nothing is best. It is only based upon It is only based upon what? It is only based upon application. It is only based upon application, right? Or we can say requirement. Application, or we can say specific requirement. Specific requirement. What is the specific requirement? Right? Understood? So in satellite missions, right? If you send a full custom based design, of course there will be some chips which is full custom, which is assigned for specific task only, right? But of course, the unpredictability of satellite mission is very high. The probability of unpredictability is very high because we don't know how space behaves, at what time how space will behave. We don't know which asteroid will come and hit. We can just calculate the projectile motion of any unidentified object which is present in space. Based upon that, we are going to calculate what will be the time and date of impact of that particular object with our spacecraft, right? Or whatever aerial object which we are sending into the space, right? But how these all things can be possible? Using programmable chips, right? Okay. So ASIC design, right? It is a integrated circuit. It is a semiconductor chips are the compact wafers that contains millions of electronic components, like I discussed. All circuits are integrated onto a single semiconductor die, right? These are just conclusion point what we have discussed just now, right? So how evolution of integrated circuit happened, right? We know the Moore's law. It started from small scale integration, then medium scale integration, then large scale integration, then very large scale integration to ultra large scale integration. What is this scale? Scale means increment of count of transistors from there to here. So what is changing? Billions of transistor. Understood? Which is enabling compact and powerful device. We are in a phase of ASIC designs. The 80% market share is of ASIC designs only, commercial market. That is what your smartphones, your wearables, your washing machine, AC, smart anything, cars, full of electronics nowadays is full of VLSI chips. Without that, it is not possible, right? So those all are what? Application specific. The major importance or the major requirement for these application specific design is what? Power, right? Nowadays what? Everyone is wanting the devices which is what? Power, more power backup or not. Why? Because these all devices are wireless. Whether washing machine we require power backup, not required. Power backup is not. It is a wired, right? So wireless requires what? Power backup, more power backup. So it should last long. This is one thing. Then it does not mean that power is not important in washing machines or air condition. Of course required. It is wired. We require low power operation of air condition and washing machine, right? So what is the second point here with respect to power? The devices should also be low power consumption devices. The leakage power should not be, means it should be less, right? So with respect to power aspect also, the design should be done. Understood? So very important nowadays. All devices which we are having, since we are going towards shrinking towards more lower technology nodes, it is very important that we optimize power also, because leakage power will increase as channel length shrinks. What is that effect called as? Short channel effect, right? You will learn that in CMOS basics if you are not able to recall. So those basics are very important, digital concepts as well as CMOS concept, to understand more advanced PD concepts. Clear everyone? So this is the ASIC complete ASIC design flow. which we have discussed, right? If any design starts from specification, right? If you want to design a car, so you must define the specification of car or not. You are going to purchase a bike, right? First, what you will decide in mind. Yes, all those are nothing but mileage, right? What will be the top speed? How much average it will give? What is the weight of that bike? What should be the weight? What should be the design of that bike? Right? Other parameters. All those are nothing but specification of the design or not. Now that is decided based on what? Requirement, application, your requirement, specific requirement. Suppose it depends on your age and requirement, right? Suppose in this age, what type of bike you will require here? You want a rally bike, which is raced in games and the sports. You want a dirt bike in Bangalore.
We need
Requirement is not there, right?
better bikes.
Why you want a rally bike or a dirt race bike here in Bangalore? You will require some good bike which gives you good mileage and which can sustain the heavy traffic. Now you bring a Hayabusa in this heavy traffic. Now it becomes very difficult to take that Hayabusa out of that traffic or not. Some auto driver will come and they will hit your Hayabusa and they will only blame you. It's your fault. Understood? So it is based upon requirement and scenario. Whether it is required or not. Of course, that is a good bike. It is a fast bike. A lot of features are there, but does not suits with your requirement, right? So based on if you are a Formula One racer, so what type of car you require, right? So in that case, you will choose, of course, the fastest car, right? Ferrari or something like that. You won't choose a Alto car or Nano car, right? It is all based on requirement, your budget and your requirement. So it is nothing. Remember this: nothing is worst, nothing is best. It is all based upon our requirements. So specification. So based upon commercial market or consumer market, so there are many people who have different requirements. So based upon that, they will decide specification. With respect to that specification, they will design that product. Like Tata. Tata have full range of cars or not, from Tata Nano to Jaguar, right? And all different lot of features. Safety features is also similar to that prices also, price range. From Tata Nano to Jaguar, safety features are different, right? So why they have created a whole lot of range? Because there are different sections of requirements, right? For that they have design that. Similarly, in a SIG chip design also, we will design multiple chips. For an example, see, there are a lot of different mobile phones, right? Whether all are using same Snapdragon processor, they are having different Snapdragon or not. One is called as Elite Snapdragon 8 Plus, right? One is 7 Plus. So what is this? Based upon the mobile phone overall cost, that particular chip will be used. If it is a budget friendly smartphone, 10,000, 15,000 phone, why I need a Elite Plus 8 in that phone? Understood? Because that is the best performing chips. If you attach it with 10 to 15,000 phone, that will not no more 10 to 15,000 more, because the cost will be high for that phone. So if you want to create a budget friendly phone, we will require what? Lower cost chips, right? So based on requirement, the chips design will be also be different. Different means what? Not only design, the performance, power and area. Best means what? It will have low power consumption, less leakage, faster performance, and area will be less. Smaller area, you will have more complex designs. So that is what we are saying difference. So all those things depends on specification. Architectural design, right? Then we need to design a block diagram for that particular, that is nothing but architectural design. What are all components required? You require display, you require memories, you require CPU. What else you require? Audio. So some audio circuit is required or not? Some conversion, DSP processor is required or not in your chip? Of course required, because digital signal processing, image processing is required or not? So that kind of circuit should also be present in your processor chip, right? So image processing is also, because nowadays if you see Samsung phones are best in image processing. Samsung cameras also best, but you will see that their image processing is more best compared to other competitors. If you take one photo from Samsung, right, it will take a waste photo only, but then it will, after that it will do some image processing and it will make that photo more look good, right? That is the magic of image processing. Okay, so architectural design, what all blocks, what all system is required in your architecture of chip, that will be decided here. Then comes RTL design. I have explained RTL design. You might have understood, right? What is RTL design? Then RTL verification. One RTL design is completed. The Verilog code, hardware description language code is completed. It needs to verify it or not, whether the respective inputs, with respective inputs, it is giving the desired output or not. So that will be verified through what? Simulator. Those simulators are called as Xilinx, right? ISC Xilinx and Vivado. All these are tools. Model Sim, Questa Sim. All these are EDA tools only, which has simulators. These are called as simulators, which will give the which we will give the possible inputs, test cases. Those are called as test cases and test benches. With respect to that, we will get the, you will check that whether you are getting the desired output or not. If you are getting, it means the design is functionally, logically correct, right? If any of the output is wrong with the respective input, wrong means what? Suppose and, if I give 1 and 0 as an input to AND, what should be the desired output? If I am giving 1 and 0 to the AND, what should be the desired output?
0.
0. Desired output should be 0. But what if I get 1 as output? It means my AND circuit is not correct. Understood? So that is how, that is what simulator will do. The possible inputs we will give into that simulator, right? Whether we are getting desired output or not, it will check. If not getting, means our RTL design is functionally not correct, logically not correct. So we have to redesign it. That's it. That is a one loop. Next, after all this, you need to convert that RTL design, behavioral design, into gate level design, because it does not have any gate information. So that stage is called as synthesis stage. Right? So synthesis people will understand how to do that. After that comes DFT. DFT is nothing but design for testability. To improve the testability, to improve the testing feature on the design, we need DFT circuits also. Right? So some scan flop, MBIST, ATPG generation, pattern generator we need. Right? All those circuits can be inserted in DFT insertion during synthesis stage itself. From floor plan, this is your physical design flow. So in physical design flow, first stage is floor plan, next is placement, next is CTS, next is routing, and last is sign off. So till routing, it is called as physical design flow, right? Floor planning, placement, CTS, routing, and sign off. Sign off is nothing but checks. Once your physical implementation of this particular design is completed, then we should have some checks, right? Checks with respect to power, with respect to timing, and with respect to physical aspect, like what, which layer is used, proper width is given or not, DRC rules, those are called as DRC, minimum width, what is the, according to foundry. Understood? Like, um, you might have seen those manufacturing plants where they will manufacture hammers. Have you seen hammers? How they manufacture hammers? They will have molds, right? They will have specific size, specific design of mold, and they will drop some melted iron, and you'll get a iron shape, right? So suppose you have given some design to that plant, manufacturing plant. Suppose your design is different. Now your hammer design is such different that it has thorns like spikes like shapes, right? But mold is not there for that. You are giving such design for that specific mold itself is not present. It means what? Your design itself is not correct. It is a illegal design. Why we are calling it as illegal? Because it is not following the manufacturing rules, foundry rules. So whatever shape mold they have, according to that you also need to follow here in design. Clear? So those are called as physical checks, right? Physical verification. So after that, all these checks, it will go to fabrication, it will get fabricated. Then that chip will be that from wafer. I have shown you that small squares, right? Each chip will be cut into one pieces, and each chip will be packaged into one plastic packaging. Right? That comes under packaging and testing. Then you will get the chip. So whatever you see in motherboard, have you seen motherboard of laptop or computer? So there will be one Intel chip or some chip, right? There will be one black square or not. That is nothing but your chip. But actually that is not a chip. Chip is inside that packaging, that black dabba you see, right? It is nothing but what? It is a packaging. Inside that we have a small chip. The chip size is not that much big. Actual chip size is your size of a fingernail. Chip size, not transistor size. The chip size is the size of a thumb or this fingernail. Right? But what is the transistor size? It is smaller than coronavirus, right? Remember the difference? Now, in specification, like I said, so everything will be decided what all system is required inside your chip. So those are called as SoC, system on chip. So multiple systems are required. We require a memory system, we require a ALU system, GPU, CPU, USB, Bluetooth, display, speaker, all these things are required. Now these systems needs to be defined. So for that we require what? Block diagram, right? So in the architectural design, what we are doing, domains means, see, everyone has roles starting from front end. So I will tell you there is a RTL team who are designing, who are writing the RTL codes. Then there is a RTL verification team. Those are called as design verification. Their work is not designing work. So whatever RTL designers are designing, their work is to verify it based upon what? Truth table, based upon stimulus. After that, we have synthesis team, we have a DFT team, right? Then we have a physical design team. Then we have a timing team, STA team. Then we have a physical verification team, power team, PDN team. Likewise, there are many power team is separate in PDN. Then so sign off teams are there, right? Then post silicon validation team is there. Standard cell characterization teams are there, right? These are all domains on, right? They all work for this complete design cycle which I am explaining here. This is the complete design cycle. It starts from specification, ends where? In fabrication lab. After sign off, after checks. In this complete project cycle, in this complete design cycle, we have physical implementation cycle that is called as physical design. In this complete flow of project cycle or design cycle of a SIG, starting from specification to fabrication, from floor plan to routing, we have physical implementation, which is called as physical design flow. Understood? Where you have to consider each and every parameter because now your design becomes more practical. It is no more logical now. Here you have to take care of length, width, electrical properties like what is the voltage, current, power, leakage. Everything you have to take care here in physical design. So whatever dreamland stories they will write in RTL code, maybe it will work here or may not work, right? Even though if it is not working, it's our job to make it work. If leakage is more, why leakage is more? I should work. and correct it. That is where designer's mind comes. The physical designers are like that. Okay. So architectural, like I said, these are nothing but block diagrams, okay, of those systems. So RTL design also I have explained, right? RTL design are nothing but the behavioral code. So this is 4 cross 1 marks. How many inputs? 4 plus 2, 6 inputs, 1 output. This is a truth table. With respect to that, RTL codes are written, right? So RTL codes are nothing but HDL codes. Those are Verilog or VHDL code. It can be written in two different languages. Those are called as hardware description language. It is not like C software language because it is having hardware information. That is why we are calling it as hardware description language. Right? I will come to those questions. Just please wait. Let me complete this. I'll answer each and every question with respect to companies and what is the opportunity, current scenario, everything, which domain is good, bad, everything I will answer. So ASIC design flow. Next is what? After RTL design, we should verify that RTL code or not. Right? So you have to write one test bench for that. For test bench, you should write what are all possible inputs. For those possible inputs, what is the desired output? And whether you are getting the desired output or not, that can be checked through simulator, right? That is Xilinx, Vivado, Model Sim, Costa Sim. These people will be using these tools, right? It is more of programming based domain. Front end is more of programming and coding based domains where you should be very strong in logics and coding and programming. Okay, that I am telling one difference this also. If you like coding programming, then you can shift to front end also. ASIC design flow. Next comes once your design is verified, RTL is verified, your design is correct, functionally correct. It is giving the desired output for possible inputs. Then you should go to synthesis. What synthesis will do? It will convert the RTL code into gate level netlist, right? It will convert the RTL code into gate level netlist. This is your RTL code, right? It will convert into gate level netlist where you will have gate information. Clear everyone? What I have explained that time? So it transforms the technology independent design to technology dependent. So it will use standard cell library names, which is technology dependent because all standard cell library is having the physical attributes, height, weight, what is the layer, poly, everything, right? It will take half an hour. I will take more because I need to take some questions also. Mukesh, how is he? Yes, I'll explain. Just give me 2 minutes. I have 3 slides to complete. I'll explain everything. So ASIC design flow synthesis, right? Synthesis, what we are doing? We are converting the non-synthesized code into gate level netlist. What I have shown in mux 2 cross 1, it is not a mux 2 cross 1. We are converting into gate level netlist. How gates are logically connected, which nets are connected to which gate, that we are defining. It is a list of nets. That is nothing but synthesis. DFT, what we are doing? Design for testability, improving the testing feature of a design. That is a DFT domain, not a physical design domain, right? By inserting what scan chains and ATPG, test pattern generator logics, MBIST, right? So this is from where your physical design will start, right? The first step of physical design is the floor plan, right? How floor plan? What is a floor plan? Suppose you purchase a house, right? Before purchasing a house, you are going to see you are going to draw the floor plan or not, like where you are going to have the compound walls, right? Where you will going to start building your house, where you will have your drawing room, bedroom, bathroom, and kitchen. Like that, you will define everything or not. So, floor planning is overall about that. How we are defining. right? So core area and die area, that is nothing but the external boundary of design is defined. Where you are going to place the ports, that is very important or not. Suppose at your home, your entrance is at east side, but you are creating the entrance door at south side. Understood? Your main gate is at east side on road, but you are making the door of the house at west, opposite side. Is it okay? So doors are like what? Ports, right? Ports are means for I/O communication, input and output communication or bidirectional communication. So it should be near where we are having communication or not. So like that, there are many guidelines which we will discuss in advanced session, how it will. Then voltage area also required, right? Whether everyone in this design operates on same voltage. Is it necessary to operate in same voltage? Not required, right? At your home, everyone eats same amount of food. Why they not eat same amount of food? Because requirement is different. If a person who is 100 kilo kg, he requires different amount of food. A kid who is 10-year old requires different amount of food. The requirement of energy is different, power is different, right? Similarly, devices which are present in design requires different amount of power. With respect to that, we will provide different voltages also, right? Then macros means bigger blocks. Macros means bigger blocks. How we are going to place bigger blocks? What are all different types of macros, right? Suppose at your home you will place sofa first, right? Or you will first place spoon and slippers. When you move to new house, you will place bigger objects or not, like sofas, TVs, almiras, right? Those are macro blocks, bigger blocks. So if you play small things first, small objects first, it will cover all your area. First you need to place bigger blocks, right? Similarly, so different things are there: tap cells and end-caps physical cells to avoid DFM. We require power planning. So once you have created your house, you need to do electrical connections also or not. Which one should get what power? No, no. Voltage area is not same as adding power rings and stripes. The stripes and power rings will be added in power planning stage. So I'll give you one example. At your home, you're using fridge, TV, everything, right? Whether all are connected through same type of wire. So different wire gauges are there, right? Some are thick wires, some are thinner wires, right? In your laptops, you are having thinner wires. Whether you can use same electrical wire which you are using at home? No, right? Because there is a different resistance for those wires, right? Based upon our requirement, we'll use the specific gauge of that wire to have the specific resistance, right? So that is the reason we will use stripes and rings based upon requirement. Rings are nothing but which are created around the macros, right? If you have a macro here, so in your design, so suppose this is your design. So here you have two macros. Now macros are what? Bigger blocks. Bigger blocks means what? More power hungry or not? It requires more power. So you can give separate power line for this. VDD, VSS. So these are called as macro rings, right? Now, thing is, suppose at your home you have placed fridge here. Whether you are going to create socket here for that particular fridge, or fridge should be placed near to socket or not, right? Both is okay. Socket can be created here or fridge can be placed here. So what is the understanding here? That devices which are placing, it should be near to supply, right? Why? Because wire length will increase. If it increases, power losses will increase or not, right? Similarly here also, if you are doing a power planning, so power stripes will be created so that we can have nearest supply. Understood? This is called as PG grid, power grid. Clear? Then comes placement after floor planning, placing the macros, bigger blocks, having a power planning, then comes placement. Placement of what? We have already placed bigger blocks. Now comes smaller blocks or not, smaller cells or not, which are not placed. Those are called as standard cells, right? Like what? And or logic, mux, full adder. Those are smaller compared to the bigger macro blocks, right? So how smaller means, suppose it is, this is your macro, right? So standard cell size will be very small compared to the macro, right? So here also we will place the placement of these cells globally, and then we'll do the detail placement, right? Means rearranging again. Rearranging in terms of what? To avoid congestion, to avoid overcrowding, to meet timing, power, and area constraint. You insert more and more standard cells, right? Suppose your sister will come at home, a new purchase home, and she'll bring 10-year clothes and purchase another 100 set of clothes. What will happen? It will require more area or not, right? But whether it is necessary to bring that many of clothes, not required, right? So you can reduce that. So area, power requirement. Suppose more and more power hungry cells are inserted and placed. What will happen? Your overall power leakage and power consumption will increase or not. Timing requirement. Suppose these two cells are placed, right? Now in design, one cell is placed here and one cell is placed here. These two cells are talking, communicating, and if it is placed far from each other, what will happen? There is a long wire, right? The R will increase or not, time constant will increase or not. Even it will have some crosstalk, right? If it is a long wire, there might be parallel running wire which is flowing near to this wire that can lead to crosstalk also. So overall, what will happen? Your time constant will increase. It means delay will increase or not. Wire delay is increasing or not. In that way, your performance, we can say that performance is deteriorating, degrading. So very important, placement step is very important. So you should take care here, right? Next is CTS. So you have done power planning and placed in right location near to those people who are talking with each other, will place them near to each other, right? Then next is clock tree synthesis. Now there are some cells which are sequential also. We are only discussing about combinational. Those are mux and full adders. All are combinational cells. But of course, there will be cells which are D flip-flops, right? Some sequential cells. So memories are made up of D flip-flops. So those requires clock or not, right? So how efficiently clock can be distributed such that clock timing can also be improved, right? Now, suppose you have many logics. Now you have port here. How you are going to connect? How you are going to connect the clock nets like this? Of means this is clock port. From clock port, are you going to connect from clock port like this? Every connection should be there from clock port, or better one is, I have port here, logics here, right? I can draw one backbone kind of structure and I can connect like this. Which one is more efficient? Second one, of course. Why? Because the length is reduced. Overall length is reduced. And you will have a better timing also with this kind of algorithm or this kind of network. But every time you will try to connect from ports, what will happen? Unnecessary wire requirement is increasing or not? Wire requirement increasing means what? So timing, with respect to timing, will also getting increased, delay will increase. Also losses, right? EM, all those things you can see. So there are many things which will happen. So efficient clock tree building, right? This is nothing but looks like a tree, right? This is one main trunk. These are all branches. That is why we are calling it as clock tree building. So efficient clock tree building is very much important for maintaining skew and latency. And we will see all these are advanced terminologies. We'll understand once we start with PD advanced session. Okay, so last step, once clock tree building means what? Clock routes are physically implemented, means physically metal layers are present, right? Now what is the last stage? That is routing. You have placed all macros, you have created die ports, right? You have placed all standard cell. Now what is the next step? Last step is to connect all these devices or not. According to what? According to what? According to RTL design. The gate level, not RTL, gate level netlist design. The gate, which gate is connected to what? Which input is connected to what? Similarly, with respect to that, physical layer will be used to connect these devices. Clear? So connection between macro, standard cell, physical connection actually. uh, and ports, right? So these all connections are what? Physical with metal layers. So routing can be divided into two parts. One is global routing and one is detail routing. Okay, once everything is completed till routing, then we have a sign off stage where the sign off means what? Final checks. Final checks with respect to timing. What is the delay? Final checks with respect to power consumption and low power devices. Final checks with respect to sign off stages, right? Sign off stage like physical verification stages like DRC, LVS, and LEC. What is DRC? Design rule check. Like I said, Foundry has some constraint. This much size should be there. You should have that spacing rules. Minimum, what is the minimum spacing I should give between poly and another poly? What is the minimum spacing between one metal layer and another metal layer? I cannot draw the metal layer connection very close to each other, right? Let's say the rule is like 0.06 micrometer, right? Greater than 0.06. Suppose I am breaking this rule and I have connected less than 0.06 micrometer. What will happen? DRC violation, design rule check violation will be there because this rule is coming from Foundry, which I am not following. Similarly, LVS. What is LVS? It is a layout versus schematic. So the layout means what? The current layout which you have drawn. The schematic means the first one from synthesis. Whether both are same or not, because synthesis is what? Nothing but a logical design. It is physically not implemented. But once we are drawing the physical design, maybe some other metal layer can connect some another metal layer. So design will be different or not? See, if I am drawing 2 and 1 or, so mux, right? Let's say this is mux. Ideally, it should, the connection, the logical connection should be like this. But once it comes to physical connection, right? Now metal layers will be used to connect these pins or not of standard cell. Suppose by chance there is another metal layer which has been connected like this during process, right? Whether it is correct, whether LVS will pass or fail. Here it will fail. Why? Because the physical connection, it is having connection here also, but logically it is not there. So here there is a mismatch, right? So LVS will fail here. Clear? So last, after all these checks, you will get the GDS2 file, which will go to Foundry, right? So these are all steps which we are having here, the layout, synthesis, and corresponding tools which is used to perform that flow. So for layout, we use custom compiler from Synopsys, synthesis design compiler, placement and routing, we use ICC2 tool, which is latest one, licensed EDA tool, SPEF extraction for RC extraction from wire so that we can calculate wire delay, right? STA is nothing but static timing analysis. It gives us the overall timing analysis where every data should be synchronized, should be present at right time, right? Right time is, I'm not talking about delay or getting coming fast, right? The data should be available at right place at right time. That is nothing but STA, static timing analysis. So that analysis, timing analysis, we will learn here also, both in theoretical and we'll see in lab also what are all those timing violation. So for that, prime time tool is used. It is also from Synopsys, very efficient tool, right? So all these tools, ICC2, prime time, custom compiler, design, all these tools are used in industry. All are industry level tool. All are licensed tool. For physical verification, we'll use IC validator, or there is one more tool from Mentor Graphics that is called as Caliber. Okay. For power sign off, we have Red Hawk 2. We don't have Red Hawk 2, it is very costly. So prime power is there from Synopsys 2. The best tool for power analysis is Red Hawk tool, which is not present in any institute. Not in some companies also. Only some companies has that tool, Red Hawk tool. It is the most costliest tool. So this is the complete physical design flow, and what we are going to learn in advanced physical design flow, we will start from here, sanity checks, floor plan. So we'll follow the complete structure here, right? So this is about little bit briefing I have given about VLSI, about what all other domains will be doing, what is front end, what is back end. So physical design comes under back end. In back end, what will happen? What is transistor count? What is channel length? What is technology node? I have given you overall brief on VLSI. What are all application? What are all future prospect for society and for yourself both? I've explained. Apart from this, if you have any questions regarding career, regarding subject, regarding concept, regarding course structure, regarding any doubts, right, or fees or something, so you can, I'm open for question. You can start asking question. I'll answer each and every question one by one. So yes, so few chat question I am going to start with. Which domain has more scope of getting into the field? Right. See, all domains have many opportunities. Majorly, the more opportunities we are seeing in front end design verification as well as back end, that is physical design. So these two domain has more opportunities, more vacancies, right? Apart from that, we have analog design, analog layout design is there, domains are there. Then we have this synthesis domain. We have physical verification. Then we have RTL design. So these domains does not require many man force or manpower. Right? They require very less person also. So that's why opportunity is also less in those domains. So majorly you will find opportunities in design verification, which is from front end, which you need to be good in coding, and secondly physical design, which is in back end. For that high level of coding knowledge is not required. In physical design you should be very good in concepts. If you're good in concept, you will become a good designer. Simple equation. Next, without, okay, this we have second. How is to physical design course better than course like RTL design? Like I said just now, I have told Mukesh that the difference clearly here is about coding or non-coding domain, right? If you see in RTL design, it is completely purely logical concepts and coding knowledge, right? Digital knowledge, digital design knowledge, digital system design knowledge. You should be good in Mealy and Murray's logics, right? The flow, FSM, right? All those concepts you should be very clear. Logical concepts. Whereas in physical design, you should be good in subjects, concepts, and somewhat scripting like TCL. That is not much required, but yes, it will be helpful. So these are the difference. Now, which one you should pick? It is all based upon your choices and interest. So you are the right person to judge yourself that where I will fit, right? which is the most suitable where I can fit, right? I cannot tell, right, where you can fit. I can tell you what is the scenario. So based upon your interest, if you interest more in physical design, then you can choose physical design. If you interest more in what? Digital design, digital system design, right? Or more coding, you can go to design verification. If you're interested in CMOS, more electrical parameters, what will be the dimension, how this will be connected, what happens if there is extreme hot weather, how to optimize the chip, how to make that robust chip, all those will be addressed in physical design, right? So the real time based challenges or real time chips is actually fabricated in physical design. So if I need to tell you in percentage in this complete project cycle, okay, starting from front end to back end, right? The front end work till RTL design or design verification is the 40% work, 30 to 40% work. Okay, 60% work is completely in back end. That is nothing but physical design work. A 5 to 10% work is for sign off checks. So major chunk, 40 to 60% of work is done in physical design work. The percent not only the it defines work, the percent also defines the time duration. Suppose you have a time duration of project cycle of 1 year. In that 1 year, right, in that 1 year, the 6 to 7 months, 7 to 8 months will be consumed by physical design. 4 months will be consumed by RTL and other. RTL is, it takes many years, right? It is not months task. It will keeps on developing actually. I will say design verification work will be taken like 3 to 4 years, 4 months. Okay, then we have layout design or these other domains, right? This will also like same range. Sign off will take like 1 month, 1 or 1.5 months. That's all. Understood? So this is about time frame and the work which is present in that particular domain. What are tie-ups? What are the tie-ups with your institute? So Chandra Shekhar, right? So tie-ups, so it is nothing like tie-ups, right? See, I have a tie-up with some particular company, but that company does not have requirement, right? No openings. So what is the use of that tie-up? Understood my point. So there are many tie-ups, the company tie-ups, we have a good relation with many companies. But it does not mean all company will is ready to take you, because it all depends on whether there is a current requirement or not, that for that particular company. So sometimes what will happen, some company will be requiring right now in this first phase, maybe some other companies will be there, they will be requiring in the last 6 months of that particular year. So it depends time to time which company what requires. So based upon that requirement, you will be getting the opportunities. Clear? So we have a tie-up or good relation with lot of companies. Recently, Wipro is requiring more number of people, like 400 to 500 requirement is there from Wipro, right? So we have a good relationship with Wipro. Recently, like 40 to 50 people got shortlisted in Wipro recently. So they will be again trained by them. So will materials be provided a day before the online session so that we can prepare for it? So all materials, if you are an online mode student, right, not staying here in Bangalore, it will be posted in your location. Okay, that material. If you are present in Bangalore or near, you can come to institute and take your materials. Both options are available. Handwritten, sorry, not handwritten, the printed materials. It will have assignment and theory notes. So once you have paid fees and complete the registration and admission process, so you will be immediately given all notes, right? It is not like after or PD advance, all notes will be provided to you. Online and offline, same class session, like whatever you are teaching, same as in offline class, same. There will be one class one single live class will be there for theory session. So I am not taking the lab session actually. As a trainer, I am taking only theoretical subjects, theoretical concepts, because I will be not available in weekdays. I am only coming on Saturday and Sunday if I am your trainer in your PD advanced session. If someone else is there, he will also be a PD expert, but he will also available on Saturdays and Sundays only. But the thing is, the live session, the live theory session is common for both online mode and offline mode or weekend batches. The theory session will be common for everyone. So there is no second theory session for some other batch. Okay. So if your batches, if there are two batch also, right? If it is starting at same time, so that time we will have single session only, not too different. If strength is more, we have bigger hall or bigger hall like classroom also. If more offline students are there, that time also we have like 100 occupancy classroom is also available where we can accommodate all the students also. If offline present, so online there is no limit. It can be any number. Regular classes will start from tomorrow. That you can check with the manager from this institute, right? When it is scheduled, whether it is tomorrow or I'm not aware of the schedule, because the first 2.5 months will be for PD basics. All basic subjects will start. So I'm not aware who is taking PD basics and all. I'm not aware of the schedule. That you can check with the manager. You have that institute number, right? You can call on that institute number. If you don't have, you visit the website. You can visit to contact us, right? You can just open the website. I will show you. You can visit VLSI Guru. You can visit VLSI Guru website and you can see here you will have contact, right? So click on contact, you will get all contact details. So we have mail ID and we have here phone numbers also. So you can call in this number 191 or 769 for schedule details. Okay. Yeah. Next what? Can you register to VTU portal, which is helpful students as the university allowing us to take course which are registered. Oh, so I'm not aware of the registration of VTU and all. This thing you can check with the manager of this institute whether that course is registered in VTU or how what will be the process of that, because this is a non-tech thing. So you can check with the manager here on that registration part. Apart from tomorrow, when will be the next physical design course scheduled? Next, this schedule wise, you can check with manager how it is scheduled, course schedule, like when it will start, what is the starting date. 100%, like 100% placement. So, what kind of job we could expect? In the starting, what would it be if any company doesn't have openings? So this is all based upon your pre-assumption. So we cannot just say what will happen after 6 months, right? So your course is for 6 months. Right now there are openings. People are getting hired. Like I said, in Wipro recently, what happened? Like 2 3 weeks, 2 weeks ago only. So many people got selected, shortlisted, and moved to the next. Still not process is going on, recruitment process. So first phase is completed where the written test was there. So most of the like 70% people has been 70 to 80%, I think. They have qualified for first round. Okay. 100%. See, I will tell you one thing very frankly that What does 100% placement means? You don't want to give any effort, don't want to do preparation, don't want to study anything, and still you want 100% placement. Is it possible? Is it practical for any person? If anyone is telling, don't believe that person. I'm telling. Without your effort, without your preparation effort, without your regular coming to class, sitting here, practicing, getting your doubts clear, don't forget about placement. No one can give you. Of course, you can give some money and you can get to some places. Those kind of things are also available in India. But if you do that, you cannot survive for a long time. We all know that those shortcuts will not survive. It will not last long for long time. It's very clear and very simple equation here, right? So we need, at one point we need to give our effort. Without that, no one can do anything for you. We know that. By this time, you should be knowing this, right? So one more thing, these jobs, VLSI is an industry where it does not work similar to what IT and software people types of jobs work. There people will be getting hired in masses, like full of trucks. Right? They'll come to college and they'll take 200, 300. That is called as mass hiring. Right? They'll fill the trucks. They'll take 5 minutes, 10 minutes interview, ask you some random topics here and there, and they'll come get into truck, their truck, TCS truck, Infosys truck, like that. Many trucks will come into colleges. They'll fill up all trucks and they'll go. That kind of things will not happen in VLSI industry. VLSI industry is a very small industry. All design work happens. So they require a good skilled and conceptually sound people. That's all. So here we are not doing lot of there will be routine task already code is developed, nothing like that. We are giving our brain day and night here. That is why you are getting a good chips every 6 months, 6 to 8 months. New chip is coming from Qualcomm or other companies, right? Because of that only. So design effort is taken. So that effort should start from here onwards, your preparation onwards. And it is not like a coding subject also. In coding subject, what happens? You learn C language, you can learn any language, simple equation or not. In coding, if you're good at C language, C and C++, because there is a oops concept in C++ which is not there in C, right? If you're good in these concepts, C and C++, you can learn any language on earth, right? Why? Because all have same things: if else conditional statement, structural statement, case statements, then arrays, function, right? In TCL also we have a kind of function, name is, it is called as procedure, raw, right? It is nothing but a function only. There's no big difference. If you know any one language, you can learn any 10 language, Java, everything same. Syntax change, logic change, logic is also same, right? Coding style change, syntax change. That's all. Logic, algorithm remains same. Of course, there are complexities with respect to experience and other stuff in software also. So they don't try to compare with the IT and software what these people are doing, because our way of doing is completely different and what we are doing is completely different. What we will be calling ourselves, we are hardware designers, and they call themselves software designers. Understood the difference here? So we are not software designers, we are not coders or something else. We are hardware designers, circuit designers, chip designers, who are working in nanoscale. We want to see something physically present or not. Software designer care about physical aspect. Nothing is there, right? No physical aspect. We care about physical aspect, even though we care about those things like electrical parameters, which physically we cannot see that. We can feel it, right? If you do not believe me, put your fingers into socket and switch on, and you will understand. You will feel. We cannot see that, right? But you can feel it. Those kind of aspect also will touch here. But software in there, we do not care about all the stuff. We only care about logical stuff in software. This is purely what? Hardware designing subjects. So don't compare apples with oranges. Both are different taste. Both have uniqueness. So are we provided with mentor to clarify our doubt on daily basis? The assigned mentor or trainer will clear your doubts. If it is a lab session, so lab trainer will be available here in Institute Invictus. You can clear your doubts from him also, right? Him or her. Yes, daily there will be sessions, so you can ask daily doubts, Manoj, or only through live session. Both, if you are available in live or offline, in both ways you can clear your doubts. Like I said, as according to my suggestion, best is to attend offline, where you can clear your doubts more efficiently. Is there a chance we get hired in product-based companies from here? Yes, many people got product-based companies, they got selected from here. Right? I cannot name all those people. Some names I forgot also. There are many people. So yes. So I will tell you this on this question, I'll tell you one more point here. Right? See,
Sir,
clearly there are three types of, let me tell, there are companies wise, I will tell you. What about companies? Like I said, there are three types of companies, right? One is what? Fab based companies. One is fabless, right? So these are two VLSI companies. Now, these are with respect to technical terms we are talking. What about business terms? So in business terms, there are different companies, different types, like service-based companies, product-based companies, right? And service-based, product-based. So here also we have fabrication, fabless, and uh, FPGA or programmable chip array, FPGA based companies, right? They develop FPGA or programmable chips. So these are separate type of company itself, right? So there are two types of companies: service based and product based companies. So what does this means? This means the service based companies are having the employees which will be sent to product based companies for working, right? So those are called as client to service based companies. This is one way. Or if you are employed to directly product based companies, you'll be directly working with the team, right? So each team in product company, it does not mean that service based employee coming from service based companies are working separately, no. So suppose there is one product, on that one product, including employees from product companies, including employees from service companies, both will be working together on one project. Now, who will be giving salary? So the employee who are belonging directly from product, salary will be given directly to that employee. If you are directly belong to service-based company, so your salary will come from service-based companies. Clear about this thing, how this works? Now, apart from this, there are some projects like these type of project are called as on-site, on-site project or on-site. So another type of project is like ODC project, offshore projects. Right? What is ODC project? So these service, it does not mean that these service companies does not have, do not have, they are not designing anything. Sometimes what will happen, so they don't have capability of manpower, right? In product companies, they will send some part of work of designing to service company. They will not ask for employees. They'll send the complete big chunk of work to service company. That is called as what? So they will send some work. So those are called as ODC projects. Now what service company? In that service company only you will have some location and you can work on these ODC projects. Right? Clear? You will have complete your own team, dedicated team. Means one or two will be there from product company. That is how it works. Now coming about salary, right? Now thing is the salary will be more in product companies compared to service companies, right? Now coming to who will get selected, right? So it all purely depends, right? So if you can see that, you know that the colleges are divided into multiple tiers, tier 1, tier 2 and tier 3 colleges, right? Tier 1s are those which you know, those are IITs, NITs, BITS, right? BITS Pilani and some other colleges, right? And IIC, Jadavpur University. Some these are what all tier 1 looks like. Then you have VIT, right? Some other Nirma, something like that. There are many tier 2 colleges also. MIT, right? MIT means Manipal Institute of Technology. So there are some tier 2 colleges also. Then we have all tier 3 colleges, local colleges. So there are some colleges like MS Ramaiah, right? These also comes under tier 2. Then, okay, RV college is also there here in Bangalore. Then we have tier 3 colleges. So all state-wise local colleges, right? State-wise, I will not name all those colleges. So all whatever remaining, understood? Now, what we understand from here. So if you are in tier 1 college, pass out from tier 1 college, so you have a high chance above, I will not say 99%, but above 90% chance that you will get a opportunity here. If you are a tier 1 pass out, you have a 90% chance of getting a product opportunity, product company opportunity, right? Directly, direct employee. If you are a tier 2, of course, the probability reduces from 90% to let's say 60%, but still you will have chances. You will have the opportunity based chances if you are belonging to tier 2 colleges. Right? That is also true from, yes, you will have. So what about tier 3? So tier 3, it is very, I will not say 0% chance, but 5 to 10% chance is there. So that is what I am telling. Even from our institute, there are many students who were from tier 3 who got selected in product companies also. So that is why I am writing here 5% to 10%, not 0%, but yes, less number will be selected if you are in tier 3, but there is a thin line chances. I will not say big chances, big opportunity, I will not lie to you. So there is a, you go in any institute, they will select based, product companies select based upon this parameter first. Rest, of course, they will take interviews and other stuff. So this is the overall scenario on the company based, right? So what are your chances if you are from tier 3? So you can join us good service based companies. Like what? Like you have nowadays Infosys, TCS people will also taking, Tech Mahindra is taking, Wipro is taking, right? And you have what? Mirafra is there. Some lot of companies are there. Mirafra is a good company. You can join there also. Digicom is there, right? So Seven Rays Semiconductor. Many are there. Then one startup company, service company is there, right? That is I'm getting forgot. What is that name? So there are many companies. Some are startup companies, some are well established service companies, some are very old service companies, right? So you will be getting lot of opportunities. So compared to product companies, one more point. Compared to product companies, you have more opportunities in service companies. I will say that 90% opportunities will come from service companies. 10 to 15 or 10 to 20% opportunities will be there for product companies. Product companies will always, they will not hire. They will hire means that period will come once or twice in a year. That's all. And that also they will hire not in hundreds. They will hire for one person, 2%. For freshers only, one or two or three. That's all. The end. So the recruitment quantity is also less in product company. That is why they will choose T1 first. They will not start from T3. If their requirement is more, then they will go to T2 also. Like that, they will follow. So in service company, the opportunity chances are more. What are those service companies like Wipro, right? TCS, Digicom, Mirafra. All these are some companies which belongs to service. Product like what? Intel, MediaTek, Samsung, Qualcomm, right? And what? Global Foundries. And there are many product companies also. There are, compared to product companies, 5 times more is service companies. Suppose there are 5 product companies, so how many service companies? 50 service company will be there. Understood the ratio? That is why more opportunities are there in service companies. So you don't have to worry if I am not getting product company. Anyway, that chances are less. They will go with first preference, this one, right? So your chances is more in service company if you belong to T3. Currently, I am in 7th semester and live in Hyderabad, so it would be difficult to attend the offline. And also, currently we have project. It would be difficult attending online session all the time. So, can I join in the 8th semester? That means we'll pass out. See, every 1 or 2 months there is new batch, right? Here in institute, yes, you can do that in this institute, right? Every 1 month, I will say every month new batch starts. Yes, you can join that new batch. If you think you have some condition, you have some situation, right? That time you can join new batch which will be starting during that time, your 8th semester time. Mithilesh, by learning this course, I can startup based start a startup based on this, or I should learn all the VLSI course. See, startup means it depends, right? What you want to start with. VLSI is like what? VLSI is like what? It is itself is a ocean, right? Complete water body. Pacific Ocean, right? Atlantic, Indian Ocean, like that. Now each one is ocean itself. You touch PD, it is a ocean. Inside that there are now many things. Your startup for touch any topic like STA, right? It is a very huge ocean itself. You don't think that it is a one line topic, right? Physical design, many things, floor plan, PNR is there, right? It is a whole lot of ocean. So here this course structure is not to prepare you for starting a new company, right? What is the purpose of this course structure? To get a job in VLSI design industry. That is also what, if you choose physical design domain, you will be more good in physical design to get hired in good company. That is the motive and that is the purpose of this course structure. Clear? If you want to start a startup, you should probably join IIM, right? And plus subject knowledge, right? Of course. I am a researcher scholar and my research is based on characteristic improvement of FinFET and TFET. Okay. Will this course help get a job? See, like I said, this course will help you, particularly physical design course. I'm talking because I'm a background from physical design. So I'll talk about physical design. So if you do the physical design course from here, definitely you will get a job related to physical design, right? But if you ask me about the characteristic improvement of FinFET and TFET, so those things we are not going to learn here, right? I'm telling you very clearly. FinFET, we are not going deep. We are not going to do deep dive on FinFET technology. We are taking CMOS technology. Like I said, it's not a, this is a structural change. That's all. So it will help or not? Because I think 5 to 10% it might help. Because no knowledge will go in waste. Sometimes it will correlate with few things. Of course, in some things it might help. But the more advantage you will not get. I don't think, because you are in a research field, and that too you are in device characteristic, right? Means enhancing the device characteristic. There is no such thing you are mentioning like designing, right? And here we are, what we are planning, what we are going to study about designing, right? How we are going to design more efficiently in less area, more faster devices, good performance, without having more core. It should be very fast, it should sustain in each and every temperature. So it is all design aspect which you are going to learn here, not device characteristic as such. For this, you for that you need to join standard cell characterization or device characterization courses. Right? I think I'm not aware of about such courses. No institute teaches you standard cell characterization or device characterization because it's not difficult, right? It is not complex enough. But when it comes to designing, each project, each design concept will change because requirement is different, right? You want F1 car or a Splendor bike, complete requirement changes, right? With that, concept will also change. But device characterization is not like that. With respect to device, only some 5 6 parameters are there which we need to attend. So not that much of complexity, or the unpredictability is less. Can we start our own startup after this course? Same question you are asking, right? I have already answered. Or do our work without joining company. That all depends on whether you can cope up or not. Yes, you can do that also. That is also possible. But it depends on company to company whether they uh, accept you as a physical designer or not. What is your portfolio? It all depends on that. By selecting in service-based companies and by gaining experience in service-based company, can I move into yes, there is a high chance. If you're working in service-based company and you have a good knowledge, you have learned lot, you have done lot of projects, of course any product company will take you. That is for sure. That will happen only. So you have worked for 5 years in service companies, 5 to 6 years, 7 years, or 8 years of experience. By that time, how much knowledge you will gain in physical design? Lot of knowledge, lot of projects you might have completed. Easily they will take you. But what I said in first phase, what I said in first place, what I said, that the certificate doesn't matter here. What matters? Your skill, concept, and knowledge. How good in applying things, how good in getting work done. Clear? If you're good in skills, good in hands-on skills and knowledge, definitely you will grow. Okay, average salary package. See, service companies, right? So here your salary will start from around 4 to 5 lakhs per annum, right? As a fresher, I'm saying. Fresher in VLSI, your electrical experience won't work here to get more salary. Maybe some company may give 1 lakh more. You have electrical experience, so they might consider in salary, but you'll be treated as fresher only. Okay. Now 4 to 5 lakhs per annum will be there, right? Provided that they will also give you some training, right? Maybe you are a fresher, so they might give you internal training also. Some companies give, some companies do not give also, that is for sure. So 3 to 6 months of training might be there. During this period they might give some less salary, not the actual salary. That also depends on company to company, I'm saying. Some company will start the salary immediately once you join. Some company will say 3 to 6 months will give you some training, will not send you to client location, we will give you some 25% of your salary, 30% of your salary, like that they will be. So it all depends on company to company. All do not follow same thing. So we cannot generalize here. But all in all, you can expect that the salary will be ranging from 4 to 6 lakh, I will say, right? In service companies as a fresher. So this range, why I'm writing range? Because again, the company reputation and company levels are different. So in service company also there are good service company, average service company and bad service company also, right? So there are levels. Then comes product companies. Product companies. So if you are a T1 college pass out, like I said, right? So they will be giving you from 10L to 15L as a fresher, right? But thing is, this is I'm telling the at least they will give. So depends on product to product company. Some might give more also, right? It also depends on whether you have completed MTech or not. If you are MTech and with T1 MTech, so you might get more also, maybe 20, right? 15 to 20. Okay. But this also you will not get it after joining the company, right? This you will get after 1 year, right? This 1 year will be the probation period for you. They can take out of this company anytime, any moment. Like recently, Intel, you might know, you might have heard, they have laid off many employees, many fresher employees after 6 months, after 8 months, right? So like product company, that considered but no use. It will be considered, you can say 6 months I've worked, but it is not having much weightage. You haven't worked on project, no? Project weightage is different than that training weightage. Training has no weightage. Means I'm talking if you have selected there. Okay. See, so after probation, you will get this full salary. So till probation, maybe you will get 30% or 40% of this. So all in all, you'll get like 30,000 to 50,000 per month in training period, possibly. Okay. Now, the chances, what is the disadvantage in product now? The chances of layoff is high. Layoff chances is very high. Why? What is the reason for this? Because they are paying high. In order to cut out the expenses, what they will do? They will lay off 100 people. Immediately, what will happen? Crores will be saved or not. So that is why, that is the reason the high paying product companies will lay off in same amount also. Service companies will not immediately lay off. They will give you chance of 3 months, 6 months to prove yourself, to get a client, to get a job in some product company. Suppose the advantage compared to with respect to layoff here is service company has many clients. Qualcomm, Samsung, Global Foundry, Broadcom, everyone are clients of this service company, each company, right? They can send you to any client, any company, right? Suppose Qualcomm requirement is not there, they will send you to some other MediaTek. They can send you to AMD. So based upon where availability is there, they can send. So that option, whole lot of pool opportunity is there. So if this is not, next project can be given to you, right? So this is overall scenario. Suppose your project is completed in one client, you will come back to this service company, right? They will not throw you out, they will send you to other client, like that. But here, let's say private company. So suppose more projects are not there, no innovation is there, like Intel, what they have. So no new thing is coming up, no big projects are there. So they have removed 100, more than 100, 500 people they have laid off, right? Including freshers and trained freshers. That is the reason. Because the dependency of private company is only on their market size, on their product market size, not on other companies. Understood? That is why service companies survive more. They can keep people more for more time. That is the reason. So of course, layoff will happen in service company also. The frequency, the intensity is less compared to product. This is the advantage of service company over product company. If you leave salary aside, the stability thing is, if you compare with layoff, this is why it is better. So this is overall thing. Any other question?
Isn't specific. What is the specification for tools? Means the laptop system.
Nothing. See, if you have a basic dual core processor also, dual core processor, it is fine. i3 is also fine. Minimum i3.
Generation.
No, nothing. i3 is a fine. This is not required. What specification you have? You tell me. I will tell you. I5. I am telling i3 only, right? So if you have 256, I say what? Even if it is hard disk, right? So it is also fine. SSD is what? It is solid state device, right? It means what? It has chips instead of having disk. The comparison is different. So it is memory, nothing. Just processor is important. If you have i3, it is good. Minimum i3. A dual core is also fine. It is less than i3. This will also work. You should have Windows. Windows also at least Windows 7 minimum. 7. Nowadays, no one is using, very less people are using Windows 7, we know that. But still, I'm telling minimum. Now you can think what you have. Sir, someone has experienced in software industry as a software developer can switch to physical design course, and will that experience added benefit? Yes, so there are three parts question. First is the eligibility. What is the eligibility here? That you should be ECE, triple E, ETC, all electronics branches, electrical graduate. First thing. So you should be at least having B Tech from these branches. If you are from CS, no, you cannot do anything in. They will not select you in. Your resume will not selected for physical design or VLSI. If you are in IT, graduate in IT, no. Now, it does not mean that these people will not go in software. Of course, we know that electronics people will also go in software field. Suppose on plus this eligibility, you are having software experience, right? Some software or IT. I will also write IT or software. Now you want to come into VLSI. Okay. I already told the difference here, right? What is the difference and what is the cost here? So yes, you can come to VLSI also with this, right? The mandatory thing is what? Graduate in electronics. So even if you have experience, now this experience will be used. Whether this experience will be used? No. This experience have no meaning to VLSI. They will consider you as fresher. You will get same salary like others. Like I said, suppose you are earning 10 lakhs. Let's say you are working in software for 4 years or 3 years. Now you are getting 10 lakhs there, right? Don't expect that you will get more than 10 lakhs as a fresher in VLSI. You will start from this salary only if it is service. Clear? So this experience will not come in any use unless and until you go into same product company on same role as a software engineer. Then you will get more than this. If you are in same role. But if you are coming in the VLSI industry, you will be treated as fresher only. Benefit means you will be means you have done coding and all, means your logical thinking is better, or you can say that in that way. In recruitment and all, you will not get upper hand. Okay, any other questions? So what is your pass out year? Can you just mention in chat box quickly? What is your pass out year, everyone? What is your pass out year? 25. So I'll recent pass out only. 25. See, one more thing many people will ask. So no one has asked this question. Usually in demo session, people will ask this, that if we are recent pass out, right? What are our options and how we will get selected? So many people will tell you that if you're a recent pass out 2025, right? So they have a very less chance of getting into VLSI industry, or they will say no chance of getting into VLSI industry, right? So it's not like that. Even for recent pass out 2025, we have lot of good companies like Wipro, TCS, right? HCL. So these MNC kind of companies, they will recruit, they will recruit the fresh graduates. They'll recruit the fresh graduates. If you talk, these are not pure semiconductor companies. Mark my words here. These are not pure semiconductor. These are having all kind of stuff. Software, IT, cyber security, everything they are having related to computer. Everything is happening inside the networking and everything, all services. But so now there are pure semiconductor service companies also. Pure semiconductor service companies like Mirafra, Digicom, okay, Digicom, Chip, right? These all are what? Pure semiconductor companies, pure service based. These are also service, but the difference is these are pure service semiconductor companies. These companies won't take recent pass out. Maybe they might take you and give you 1 year of what training and all. Some companies will do, but that chances are very rare here. So I'm not saying zero chance. Of course, in pure semiconductor service companies, less chance, but here we have MNCs, so these people will select fresh graduates. So for fresh graduates, you have high chance here. If you have a gap, you are at 2024 pass out or less than that, 23, 22, 21, 2013, you have high chances in these companies, pure semiconductor service companies plus product companies. But this is not a easy task because the requirement itself is very less. So high chances here. Clear? Any other question? Okay, so there is no question. We'll stop here. I'll wait for 2 to 3 minutes. If there is any question, I'll answer. Okay, otherwise, we'll stop. Okay, thank you, everyone. I hope you have learned today something and hope we will meet again if you are interested in physical design. Yes. If any questions, you can post in chat box or you can ask me directly. Will you teach PD? I am teaching PD only here. But whether I'll be teaching for your particular batch or not, that I do not decide actually. That part is decided by management. Based upon availability and other things, from tomorrow course will be start. This question, Mitlesh, you please check with the management itself, right? Whether what is the schedule and all, because based upon the students' feedback and what will be the schedule, it will be decided whether it is tomorrow or next week or how it will work. See, anyhow, 2.5 months. So you will be learning PD basics. Even though if I come for your batch, I'll be coming after 2.5 months. So you'll meet me, you will see me after 2.5 months or 3 months. Thank you, everyone. My name is Abhi. You can call me as Abhi, right? Full name cannot be told. We also work on hardware into the lab. Yes, sir. This is purely hardware design only. Shivansh, this is purely hardware design. Lab means what? EDA tool. You are going to design circuits in EDA tool, considering all physical PPA constraints, logical as well as physical constraints. Logical means what? Timing constraints, performance, delay, speed, power is what? Electrical constraint. Area is a physical constraint. PD means everything you should be master. In DB or front end means only code, logical, that's all. And throw it to the synthesis team, throw it to PD team. Anything comes up, they will handle it. We will not think about all other external factors or internal factors, noises and all. We have to care everything: noise, delay, timing, logical, practical, physical, non-logical, everything. TD person. It is a purely hardware design. So since it is a nanotechnology, we need tools to design. We cannot do pen and paper design. Billions of transistors are there, right? How you are going to use pen and paper hardware design? You cannot see from naked eye. That's what I have explained in first place. Okay. Thank you, everyone. We'll stop here. If you have any question, get there are contact numbers and mail IDs. Better contact in phone calls. I have shown you those, right? In website you can visit. Contact to the management. If you have further more questions regarding fees and other stuff, non-technical stuff apart from course structure, you can ask anything there. Okay. Thank you, everyone.